you got to be careful giving any talk on AI these days, because whatever you say will be obsolete in about a month. So I'm just going to, for the record, say that today is March the 16th. It is 8:45 a.m. in the morning. This is what I think about AI as of today. And will I think the same thing a month from now? Absolutely not, nor should anyone. I do think there are some stable tenets, so it's not all like chaos, but I can't underscore enough how quickly this technology is changing, and in my view, how very poorly it's understood. I have a lot of apprehension about whether companies and whether governments are going to get this right. So I hope you have questions. I am not going to fill all 45 minutes with remarks. I would love to hear from you, because we're all seeing this issue that's going to transform society. We're all seeing it differently. Now, I brought my computer up here because I want to underscore the difference in the world today. The reason I have it is that I would never give a 45-minute talk on AI if I weren't running my agents autonomously in the background, because like my human time is worth about 1,000 times in its value in agent time. They are always constantly running for me. I consume about $1,000 worth of tokens a day, right? And I expect to be able to force multiply myself by at least 10x, and I'm hoping for 100. And all of my life now is centered around trying to be a good coach, a good quarterback, sometimes a good a mentor to agentic AI. And if you're not living your life this way, if you are, engaged professionally, then you probably understand AI, at least as I see it, a generation older. And so if that's a new idea for you, then this should hopefully be a good talk. Challenge me on precepts. I may come over here and get my agents going again, because again, my time in real time is not valuable if the only thing I'm generating is human outputs. That model, I think, is going to be dead pretty quickly. So show of hands, who thinks they understand AI? And that I don't think anyone should raise their hand. All right. So I don't. I use it a lot. I'm trying to understand it. I'm running a company that is very engaged, not in the AI, but in how to guardrail it. So this is something I live with every day, and it changes for me. But let me set the stage for you, since this is new for everyone, including me, and it's good for me to remind myself what's actually happening when I use any of the language models, and now increasingly narrowly defined models that can work with them. Good to remind ourselves, because we love to assign human properties to machines. Like we do it to machines, we do it to animals. As much as we know the science of how canines interact with people, that they really don't understand us, that they are so good at seeing our expressions and reacting to them as if they feel remorse and things of this nature. We know that, but at the same time, it doesn't change the way we interact with them. We do turn them into people. That's one of our strengths. Human relationships, human language, human communication. I'm certainly, not an anthropologist, but I appreciate that when humans made their breakthrough in being collaborative, that advantage, right, really led to where we are today. So we're great at it. I transition from how we interact with canines and cats and pets of all kinds to what happened when first chess and then Go, two games that historically the best computers to play them were inside some human brain. And the nations of the world vied for various soft power benefits to always have that best brain be, under their flag as a show of like national power and just the acumen of the people that were in their population. You all know that now we will never be the best chess players again. We will never be the best Go players again. And I'm not a great chess player, but I do enjoy it. And when I try, and this is like when I try to understand how an AI plays chess, and you read academic papers about it, you start reminding yourself what AI really is. When chess and then Go, if you've heard in Go, there was like a special moment called move 37, 37th move of the game, where it was a phenomenal move, a beyond human move. Shocked the world because this happened like 5-10 years earlier than anyone thought was going to happen. Move 37 was brilliant. And the first like beyond human playing of the game of Go, arguably the most complicated game that humans have created. And of course, when something like that happens, all the human experts want to understand. Same thing with the great games of chess that have been played by AlphaGo and AlphaGo Zero, and now, models that you can run on your phone that can beat all of human wisdom in chess together. And when you start reading analysis on it, you realize a human tendency that can be a weakness fast with AI is that we like to put words to things that are really math. So let me say it one more time. We like to put words to things that are really math. How many people are like a daily user of a language model, a Chat GPT or Claude or any of those? Who uses it every day? Yeah. Who uses it about once every 5 minutes? Who's running agents in the background of their personal or professional lives? Who, since they've started running agents, have found that their entire life has changed to revolve around them? Well, I don't think I'm going to be the only one here in a couple of months. So that gives me a sense, right? We've got a broad diversity of users of AI, some that I would consider more of a casual user using it every day, a few super users, a few agentic users. And I certainly don't consider myself an agentic super user, but I live my life differently now since I had this crossover moment. So let's go back to words versus math. When you work with a language model like ChatGPT or Claude, I mean, don't you find yourself interacting with it as if it's human? Like, aren't you trying to understand the way it's engaging and bringing information in human terms? But we know intellectually, it's just math. That's all we're asking the language model to do, is to take human language. It gets turned into a vector, which is just a direction in math. And then it gets mapped through a bunch of different transformations. It's kind of like a projection on a map. But that map isn't geography. It's a map of all of the data that AI has been trained on. And what makes AI amazing is that you can take data that's the whole of the internet and make a very efficient model to do this mapping. So your query becomes a direction in this mathematical space. Like, it makes sense math-wise, hard to put words to it. And then the AI is mapping it to different projections, just like projections on a map, but it's a map of data. And then out comes a vector. Then that gets converted back to language. And it's amazing. It is amazing how good it is. You can ask an entire universe of questions, and it will get you to the ballpark of your answer. But what's really hard, and this will be a topic we'll come back to, it's really hard to get from the ballpark to your seat. That's different. But when I engage, even though I'm doing this, I find myself in the trap of thinking thinking of the interactions in terms of words when it's math. Who's heard the term hallucination with AI. So about everyone. That is like, I might be alone on this. I think that is quintessentially capturing of this notion of words versus math. When Claude or ChatGPT give us an email or a picture or whatever we're asking it for, something that is beyond what we have done, that's better than what we even knew to ask for, do you think this is a hallucination? No. Do you congratulate yourself on how good your prompt was? Yeah, human tendencies. When you get something that is factually wrong, that could be risky for you to make a decision on, you call it a hallucination. Most do. Do you think it's different math? No, it's the same math, two different human words. Now, why do those hallucinations happen? Well, they happen because if we created a mathematical model that didn't compress, which means to like make efficient, the training on all the information in the internet, if we didn't make it efficient, it would take forever. Forever. It would have to run through everything. What makes it amazing is that all of that information that's in recorded digital form becomes so efficient that you can ask a question, any question, and get something pretty close to what you intended like that. Because all of that information becomes a set of numbers, and those numbers define the mapping in the data space. Not like, it's like a projection on a map, but it's a map that somehow represents all of that information really efficiently. But anytime you have a process that goes from something big to something smaller by math, you're going to lose information. Can't not. That's what we wanted. We wanted something faster and more efficient. So we asked for that. People here at Georgia Tech who have been researching, and with academicians over the world, they had been researching neural net models since the 50s and 60s. And what's happened is research has found forms that are very, very efficient and that don't trail off no matter how big the data sets are. And now fast forward to today, well, like, why didn't this thing happen in the 50s and 60s? Well, like computers were slower and we didn't have all the data, right? The internet, when it became the Internet of Things and we needed to have data in a machine understandable format, perfect. Like perfect. Machine understandable means we are ready to build those very efficient models of all the information. And so the math got applied. There's a famous paper written by Google, Inference is all you need. And that was got it. We can finally take all of information and represent it as one thing. And we know those things as large language models. We call them ChatGPT and Claude. We treat them like people, but they are just math. And so when you have that loss function, where you go from something big to something small, everything kind of moves around a little bit in those maps of the data. That vector that your original query, your prompt represents, it gets converted into a direction. If you imagine like a shadow gets projected on a sundial, it's being projected back and forth and out. And so, yeah, it's very possible. There are projections in that space that correspond to nothing. Gobbledygook, right? Because it's probabilistic. And the models are run with things like temperature settings, which is a setting about like how much randomness will you allow in to see that if just a little tiny change puts you in a completely different place on the map. And so by the power of math, the exact same math that crushes it, writing your emails and generating pictures and everything else, by the same math, you will get hallucinations. There's no way to take it out unless there is a different kind of math. So I stress this a lot when I talk with government and industry leaders, is that eventually that term hallucination, I think, will not be like a problem to solve. It'll be a power to harness, right? The power is it will create things better than we knew to be asked for. But it comes, just like any power, it's a two-edged sword, is that if we want something very specific, very correct, very niche, that's getting from the universe of questions to the ballpark. That's not that. It's getting from the ballpark to your seat. If you work with AI frequently and you're trying to get a very precise answer, especially if it's something that's not broadly represented on the internet, that's where you start seeing hallucinations come in. I'll give you an example of what I see all the time. I use AI to do a lot of math for the company I run and then turn it into code. And I find that when I'm working on the code side of the AI, it is awesome. You can create a cathedral of infrastructure overnight, like build Rome in a day. Well, we can't do that in our physical world, but we can in our digital world. The first time that I did that, there was just this feeling of power, like overnight, boom. What would have taken a year for me to do individually, boom, done overnight. Then I had to tear the cathedral down because I was learning how to work agentically. I asked for way too many things in one go, and I had good and I had bad, and I couldn't sort out which was which. Tore that cathedral down, built another one, had to tear it down. And every day, this is what I'm learning as I work with AI. Now, what makes you tear down a cathedral in the work that I'm doing? Well, the code side of what the language model was doing was awesome. But as I pushed it into narrower and narrower fields of mathematics, secure computing, and encryption, less data. Now, the likelihood that I'm going to get the right code answer and the right math answer, that's like Ulysses trying to shoot through the axios. It's just the probability is way too small. If I did it over and over and over and over and over again, how would I know which one is the right one, the right arrow shot, right? The right projection through the maze of maps that comes out. It's really hard. It's really hard. The more complex the task, the harder it gets. And it's because the power of it is that it can do almost any task I wish, but I can never know if the output is correct unless I check it. And so we'll come back to this idea of guardrailing AI, which is what I think will be required. It's what governments, what industries are going to need. The AI Olympics, as I call it, is happening right now, where people are just doing amazing feats with AI, and it shocks the world, it shocks the tech community. But after the AI Olympics is over, the lawyers, the CFOs are going to wake up and say, we just spent a ton of money on AI tokens. We're not sure we generated any revenue with it, and we're not sure that we have anything that we can trust. But we know we've got to do AI because it's the future. I think that'll be the next discussion that happens in industry. So we have this inherent dilemma because of the technology itself. It is math. We can't change it. This thing that we think is a problem is actually a superpower. Hallucination is a superpower. So how do we deal with it? Now, before we leave the world of math into the world of application, I want to make sure, because I don't want to leave anyone behind, does all of this make sense to you? You don't have to understand math. Does it kind of make sense what's happening under the hood? It's okay if you don't want to put a hands up, but if anyone's willing to tell me. There are no brave people in this room, or other, I've done a horrible job of describing what is under the hood. Yeah. This is going to be a problem everywhere. Like last year, one study, a study that was done by a major auditing firm, found that 47% of enterprises had made a critical decision on hallucinated data. Now, why? Are they stupid organizations? No, it's just how do you know? Right? There's no fingerprint that's left over. 47%. And the irony is that auditing firm was also caught in a scandal using hallucinated data to do audits of governments. And it was found. They were citing cases that didn't exist, precedents that sounded great, because between cases that really did exist and the theory of law, the projection ended up in between. It took precedents and kind of took practice and it merged it into something that had never actually happened but sounded like it could have. And that's fine if you're writing an email. Like the email that I just sent before coming up here, it didn't exist before I sent it. I didn't have a preconceived notion of like what it should be other than the content. The AI crushed it, and boom, sent. But if I need to reference something like a number or a fact, whew, now I'm in trouble, right? Because I get something that sounds awesome, sounds right, but could just be the same math that's powerful, giving us the most credible fake of history. And we hit send. 47% of companies did that. And 70%, by a different study, 70% of employees are copying and pasting proprietary information into language models when they shouldn't be. And like 15% are doing it on their own personal IT if their company doesn't allow it. Like shutting down the IT is not stopping it. It's such a powerful way to work. And only 10% of organizations have anything that can do auditing. And there is no auditing for hallucinations. It's just knowing if people are using AI. So it's a big problem that will keep getting bigger and bigger and bigger. Things that I think will happen in the near future is the hallucinations across all the life cycle of a company. We're going to keep having tails like that. Someone made a decision and it was bad. I also expect we're going to start seeing people collaborating, able to reverse engineer the intellectual property of others when that wasn't what was intended. And I think within the defense domain, we'll start seeing that all of the unclassified information in the world, which we all know if you get a lot of it together, you can aggregate, like we know that intellectually. Occasionally that happens when there's a big exfiltration of data. Government officials will go back and say, you know, if we put all this together, we can derive classified facts. And that encourages the government to not have those exfiltrations, but they always will occur. Well, there's only so much humans can do. If the aggregation has to be done by humans, that's slow. That's real time. That's the clock that I don't want to live in. I want to live in agent time on my computer and in the cloud. Well, when it's AI that's doing the aggregating, I think we're going to find that the unclassified domain is rich. Rich. Sir. If you check them, because it'll give you a link to nowhere. Oh, it will, and it'll sound great because it's got references across like every paper ever written that's in a digital form. So it knows how to make really good references. That's what you're asking for, right? It's not wrong. You're asking it for a reference, and it's like somewhere in that mathematical space, there's a projection that is like reference-like, and you may get a real one, you may not. So really want to, like, I see companies and government officials thinking that like eventually it'll get fixed. In my view, it's just going to get better and better and better. But if you're doing one thing, like find a blog for me to read on AI, that's easy for us to check. That's the Chat GPT era of AI. You click on it, you're in it. And this is a pretty good transition for me from ChatGPT into agents. But let me take the one question here before I do this. So keep in mind, like ChatGPT, you ask a question, you get a thing, you can click it, human, you're in the loop, you can do it. Sir. For risk to society, I don't. This is the biggest risk to society since nuclear weapons became possible. But where I think it's different than like a drug trial's risk is that a drug trial is part of a process where we use the scientific method to go from a hypothesis to what we believe is fact, established fact. Yeah. Yeah. That's back in words versus math. See, you're wanting to take us into, okay, I get it, it's risky, it makes mistakes. But if it's like drug trials for pharmaceuticals, then it's part of a scientific process that will iterate us towards truth. We are pulling out the errors, we are reinforcing the facts. And in my view, that's never possible for AI. It's probability. It's like asking if it's like asking a dice roll to, and being angry. It's like you want the randomness, but you also want the same number every time, and saying I want that together. In my view, the issue of hallucination is not a problem that you can put into any scientific process and fix because the math says it won't. It's probability. We want to have this go from something big to go to something small step. So these things can run very, very efficiently at machine speeds. That's the superpower. My view, because of that, there are dice rolls everywhere in it. We can't ask the dice to be a dice roll that has the power of probability, but then also have the same number on every face. And in my view, we're inherently asking for that. And I think that that's also how companies and governments approach this, is we'll put it into this trial process, and then we'll see how things go, and we'll fix those things, and then we'll eventually get to good. Sir. Right now, the whole legal precedence of AI defense, AI compliance, there really isn't. This is an area that I would wish for leaderships of government right now is you'll never drive the AI, and I don't think anyone would feel that way, but boy, some safety frameworks, accountability frameworks, compliance frameworks, they'd be super, super powerful. Now, let me tell you one thing that I said, but I want to go back to the change between what I call the Chat GPT moment that we all went through as a society, and what's changing now in the era of agents. So had anyone heard of GPT, general purpose transformer models, before Chat GPT? Yep, me. Was a GPT-3 user, and I thought it was awesome. I mean, incredible. Did work designing like airplanes with GPT-3, and I thought it was incredible. And then Chat GPT came out. And from the very first moment I used it, I knew the world would be different. Did not think that during GPT-3. Like, I knew that within these kind of thin disciplines, that these models would come in, be part of how people did work. Kind of like a search engine on steroids, except you could also generate things. You know, it's like we've gotten used to there being a generative capacity in search engines for a long time, right? The first time we started typing and Google could complete our sentence, we're like, oh, that's exactly what I wanted. So it's a generative step, right? Google has all the searches of everyone, so it's very good at guessing what you want. Well, GPT-3 to me was just a search engine on steroids. It was able to not just complete my sentence, but in some cases complete my work. And then ChatGPT came out, and it was like, this is a faster way to get information of all kinds. If you had asked me to give a talk on AI then, I would have said this is going to be the way that all humans interact with information. It'll be part of our daily lives. The search engine as we know it today will get replaced by this, and we will get better and better at doing this search on steroids that we call a prompt, where AI brings us back the information we wanted. Now, if you had asked me, will this be awesome for society? I would have given you some cautionary tales, but generally I felt pretty darn optimistic then that this was going to get out a lot of inefficiency, especially in industries that I'm very familiar with, like aerospace, where there's just a lot of time spent trying to get information. I thought this will eventually make those problems go away. There's always a human in the loop. I would have expected, yes, things to accelerate. If you had told me, hey, Will, I think it's going to be a factor of 3, a factor of 5, I wouldn't have argued with any of that. If you had asked me, will it be a factor of 1,000? I would have pushed back. I would say, got a human in the loop. You're clicking. You have to check that link, check that answer. You have this software process, and then we have a human process working by a very different clock on a very different salary. And now if you want to fast forward to where we are today, have people heard, I've got some agentic users, but have you heard of agents? Have you heard that in the tech sphere, AI agents? Well, it means what the word says, agent, agency. These are AIs that we are giving agency, including the agency to work together. And what makes them really powerful in my view, again, as a non-AI expert, just someone that's using this a lot and running a company trying to make this technology safe, what makes it powerful is that there is a language that AIs can work together on and can work with us that make the ability to truly automate tasks that would have taken years possible if you get 1,000 things right, maybe 1,000,000, maybe 1,000,000,000 things right, depending on the complication of the task in the guardrails of that system. Right? It's powerful if you build the framework to trust it. And if you don't, then you'll do what I did in my first agentic Olympics, is erect a cathedral of infrastructure overnight and then tear it down. Because somehow you let something in. You can't put your finger on it because it's lost in what could be thousands of agentic interactions, and now you don't have a thing to click on because you let the AI do the clicking. And it click, 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 and it's not traceable by you in human time. If you ever have that doubt, you got to tear down the cathedral. All that infrastructure as code that AI built, all of the repos, all of the folders, all of the unit tests, everything. Tear it down and start over. So I did. I've been doing that for many, many weeks now, is learning to do this. What allows this at all is that there is a language which we call software. It's the language of Git or the repo, which is a powerful language, not just for understanding things, but for doing things. That's a really important point. One of the first things we talked about is words, not math, right? We want to use words, but it's really just math. Second thing is that software and GitHub, if you've heard of that, the whole having a repository, the framework for that, it's not just a thing that's running code, it's a language to understand information and take actions with it. Right now for Google, I think there are over 1 million developers that they say are currently making Google worldwide. And how can they all be working together on something as complicated as Google, as a set of software running on everything? In 2017, Google published a paper saying that they were running 150 million unit tests, test checks on itself, guardrails on their system, and they were rebuilding themselves every day, 150 million. Well, that's in 2017. I mean, who knows what it is now? But for what Google does, the complexity of their guardrail system was 150 million things that needed to be checked every day. And for what I'm doing, it's not as many as that, but I'm starting to see yeah, that's what has allowed the software industries to be global, to have so many people working in a source of truth, not a copy of it, the actual source of truth, and make changes and merge them without breaking the system. Being able to track that globally, that power is what has changed the world. As Mark Andreessen said, like software eating the world, like we've seen that. But if we think the software eating the world wasn't just what the software did, it left in its wake a language for understanding information at a machine level and taking action with it. And that's what's allowing agentic AI to be so powerful for those who are doing it. Because we humans have a human level of understanding of software and this repo structure. AI really understands it. The best thing that I ever get out of AI is when I ask it for something in code speak. I even get a very different performance if I ask for, say, a PowerPoint slide. If I ask for an HTML version of it, like a website, I get a different level of performance because I'm in code speak. Well, that's what's driving those who are doing agentic work. And the reason it's powerful is that those repo frameworks allow you to automate actions. There's other really important things that come with it. Has anyone heard of like hashes for the internet, like hashing code? Yeah, I got a tech guy here. Well, hashes are really important. It's a technology that frankly was invented back in the 50s at IBM. And it's a way to take any kind of piece of information and convert it to what's effectively a number, a string of characters. What's amazing about hashing is that you can take any piece of information, right, which means we can write it in terms of ones and zeros. And if we create a hash of it, no two pieces of information will ever be the same. Right? That's math. But power of math is a different kind of math, but power of math, like we really like having the power of math because we can prove it. So hashes are how the internet works today. How do you know if this thing sent to you is the same as someone sent it? You check the hashes. Well, that's just an example of a thing that I'm going to guess most industry leaders and government leaders have no idea what it is. But in building guardrails, there couldn't be something more important to me, because once I say something is true, if I let it go through the AI gonculator, how do I know what comes out the other end? Like that was been clicked on 1,000 times. How do I know that? I have to have the power of math, deterministic math on my side. Hashes are an example of that kind of framework that is part and parcel of how software is developed today. How do you know if code written a year ago is the same code that's being run on your machine today as you check the hash? It's an example of something very technical that is quintessential for understanding how to guardrail these systems. And the reason that I'm really pessimistic on industry and government adoption in time to drive the compliance framework, the guardrail framework, is that I've been in the US government. I am used to everyone being able to parrot everyone else's talking points and have no idea what they're talking about. But that was okay when the talking points moved at human speeds, right? Now they are moving at digital speeds, and you really can't float above it the way that executives like to. I saw this personally when I was managing the Air Force and Space Force, all of their tech, and software containers came out, which was a big infrastructure as code breakthrough. And what a container did, this was Google that developed it and then open sourced it. They anticipated that, yeah, this Internet of Things is going to force us to change how software works. And the reason why is that we all brought in a different edge device. And how could we possibly make a unique version of software for everything? So instead, let's change the way that software is built so that it runs the same way everywhere. Like when this came out, I threw the hammer down on cloud adoption in the Air Force and Space Force because I knew we could have a hybrid approach. We could move our stuff back and forth, wouldn't care about the little details of the environment. It would run the exact same way. Used it to move things from our cloud development environment to the edge because I didn't need to run it on the jet. It ran via containers in our cloud, so I knew via the power of deterministic math, right? And I think the last thing that we did was we showed that for a U2 a U-2 spy plane, that we could send a live code update to a jet while it was flying. Never been done. Right? The AI actually that we also put on the jet just because it was cool, it got the headlines, but containers were the hero. They were an example of a technology that changed the calculus. If you go back to government talking points during that time, no official was talking about containers in a very, it's like too complex, like Kubernetes, I don't know what that is. I can talk about software, I can float over details. I don't feel comfortable in this. That's what I worry about. Really worry about the technical details that you need to guide this safely. In my view, they exist in the world of software, but they have to be reported and reapplied, and then hopefully steered by regulators who can say what level of safety is safe, because there won't be a perfect solution. So someone's got to draw the line, just like we do in every regulated industry. Sir. It's actually, well, yep. So, 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 yep. So, 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 sir, let me tell you, I've got more than enough fodder to pull there, and I do have to bring this home in time, human time, right? Because we still live on that. Yes, like my wish yesterday is that there was an independent effort, hopefully collaborative, allies and partners on how do we allow decisions with AI? Because we have to have a set of like Google does. Like Google, I'm going to run 150 million pass-fail checks, and that tells me, Google, that I am good to push this code update. There's the equivalent of that. Like, what would you check for an airplane? Are the requirements met? Are the supply chains met? Do the parts integrate together? All the things that we check between the things can be turned into software checks. Now, why not just have the agents check it? You can, but how do you know that? How do you deterministically know that what they did is something you can bank on? And that's where this idea of the hash, like this is something now, truth in advertising, something that I help companies with today in the company that I run. And a good example, it's in the public domain, is Blue Origin. So they announced at AWS reInvent that they had built a lunar battery completely agentically. They went from a prompt to final article, one shot. It's pretty amazing what this lunar battery does. I mean, these are brilliant engineers that I got to work with, but it sucks up regolith on the moon, that's moon dust, extracts the heat out of it like a heat exchanger, then pumps it back so that you can reuse it again the next day. It's vacuuming the moon basically to make electricity. I mean, what a alien, it's an out of this world idea, quite literally. The fact that AI was able to do it, that gets the headline. But the work that had to be done by their engineers and a lot of mine was designing the guardrail system for that. So that at the end, it wasn't what the AI did that was the only headline. It was what it didn't do. So we were able to deterministically prove through the power of different math than the AI model applies that the requirements were met, the integrations were met, the compliances were met. Basically everything that if you don't know them, you're not accountable, you turn them into tests, into guardrails, and you check, 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 check. And so that at the end, the only thing that's left to do is know, did the AI do a good job engineering? Right? It does. The guardrails don't tell you the AI is going to be a good employee, but it takes away all the things that make data not decisionable. And in the case of designing this moon battery, the AI crushed it. It was 75% faster and 40% better than human attempts on its first shot. And that, to me, that's going to be the future of industries and of individuals, is we are no longer inside the clickers, the content creators. If you like music, we're out of the studio. Like, we are too slow to be recording artists anymore. But we are still in the producer's booth with final release. Like Motown's first #1 hit, Mr. Postman. It was not a hit as recorded. It was overdubbed and EQ'd, compressed-gated. It was produced. It was engineered into a hit. And that's the engineering that we have to do societally and personally, is how do we engineer the producer's booth, the test, the equivalent of the EQs and compress gating, such that before we release something that has been generated with probabilistic superpowers, that we have enough of those unit tests, enough of those guardrails that we feel confident releasing this out into the world. If you get it right, you get what Blue Origin did. You get to go from English language to finished thing. And although most will note how long did that take to run on the computer, the human process is, well, for you all, what happened before that? How was the guardrail system built? So what should government and industry officials be doing today is determining what is an acceptable guardrail system. How well should it work? You know, and for what purpose, right? Generating an email, one thing. Generating something that life and limb on the moon will depend on it, different. Predict that we will see a future. It's not going to be, designing like a whole rocket or a whole airplane is not going to be here soon, is my prediction. We're going to see amazing feats, but the reason that we're not going to see that soon, probably 10 years out, and I know that estimate's wrong. I know it's wrong, right? But I have to, if you ask me today, and I've told you what the date and time is, that's what I would say, and I did. So it may be 10 years out, but that will happen. The guardrail systems, because they can be written by software, they'll eventually be a billion, a trillion. I mean, it'll just keep scaling. Every problem will get turned into a new guardrail. Oh, this thing went wrong. We'll fix it forward by writing a new test so it doesn't happen again. Repeat, 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 repeat. And agents can be part of this. You get this flywheel going. So if we had the framework where the flywheel can get going inside, yeah, eventually you'll go from building a part to building a subsystem to being, and it'll just expand up. Can you imagine what it'll be like to be in a boardroom or commanding a battlefield when you can push a button and some effect that would have taken 1,000 people, maybe 10 years, you can push one button and out is going to come something that may not be good, but that meets all of your requirements and compliances, all of that stuff. But that button push is $50 million in compute. Could be more. No one knows today. Right? Takes $100 million plus of electricity to just train these large language models today and going up. Can you imagine what it'll be like to be in a boardroom when they're like, we can push this button 5 times. That's all we can afford. Do you think they're going to say, well, let's push it? No. They are going to ask about that guardrail system. They're going to want to know first, nothing bad can happen. And then secondly, they're going to quickly want to know, guardrails aren't just about keeping bad things out. They're about putting that AI performing artist in the studio, putting them in the zone so that they can be a star, so you can release a hit. And I think without that guardrail system, without a human ability to look at it and approve it, then the complex things that agentic AI can do, has been doing on my computer since I've been up here. I can't wait to see what it finishes. I'm truly telling you this, because its time over our last 45 minutes is 100x like what I can do in human time. Right? When that is the case, when that is true everywhere, there can be nothing more important than for us being able to ask pass-fail questions of it, because that is what we expect in regulated industries. We live our lives this way, of knowing what we can trust and what we can't. And without that system, we'll still be looking at dice rolls, which is all that's happening in this projection of our vector through these different mapping systems. It's rolls of the dice, rolls of the dice, rolls of the dice. We'll never be able to ask that math to behave differently. And the fact that we still are tells us that we are putting words, human words, to math. We like to anthropomorphize things that otherwise can't be understood that way. My hope is there'll be a champion with the right authority to remind us that it's math, but that's how the internet works. That's how the world of software works. And if we harness the power of math to create guardrails for AI, then that hallucination problem truly is a superpower. Thanks for your time.
Good morning, everyone. If you would please take your seats so we can begin on time. I'm a big fan of Don't Punish the Punctual. So it is my distinct pleasure to be moderating this panel in this very important colloquium that we are holding, thinking about the intersection of AI and international security. So as a couple people have commented to me, earlier this month I was in Singapore doing a number of different talks, and whether I was talking with MINDEF, their Ministry of Defense, speaking at RSIS, questions kept coming up, being asked of me, looking for me to answer with regard to governance and the implications and what does this mean at a strategic level. Hopefully I provided some good answers. Today we have 2 fantastic experts to talk to us about demystifying the AI. First, coming to us virtually because of the thunderstorms. We were hoping to have her here in person, but unfortunately, Mama Nature had other plans. So Dr. Jessica Inman, she is Division Chief of the Assured Software and Information Division and a Senior Research Scientist within the Cypher Laboratory at GTRI. Jessica holds a PhD in mathematics from the University of Florida. Her interests include trustworthy and resilient AI, adversarial AI systems, and AI/ML for cybersecurity applications. So she is a perfect person to translate some of this cutting-edge science into what it means in the applied realm. And at the literal forefront of pushing back the bounds of science, we have Andrew Chin. So Andrew is a PhD student in the System Software and Security Lab here at Georgia Tech. So he is the one who is literally doing the research, pushing back the bounds of knowledge. As we all know, the professors take credit for it, but it's the PhD students who are actually doing it. He is advised by Professor Tae-So Kim, who sends his regrets. He had hoped to be with us as well. Andrew is a core member of Team Atlanta, and I think that might be a little bit of a lowering of his position. I believe he actually is one of the leaders at Team Atlanta, a multi-organizational collaboration that took first place in the DARPA AI Cyber Challenge. And we took first place by a significant amount. It wasn't just edging. Andrew is part of the C-Bug finding team, where he led integration and orchestrated fuzzers into the team's C cyber reasoning system and developed the LMM tools and agents to assist with vulnerability discovery. Okay, so with that, I'm going to begin the questions. I'm going to start with Jessica, just because she is remote, and then we'll go to Andrew. So for both of you, I would like you to describe your experience and your area of expertise in AI. You know, tell us the relevance, tell us the scope of what you are working on. Jessica?
Awesome. Thank you so much. Super happy to be able to participate, even as you mentioned, even with the travel difficulties. But so my research really focuses around making AI deployable in high consequence environments. A lot of AI systems traditionally have been built for low consequence environments, things like searching for videos on YouTube. And we really want to be able to use these amazing tools in high consequence environments like, DoD, military scenarios, places like finance or healthcare. But we have to bridge the gap between some of the academic research that's happening and being able to reasonably deploy these things in cases where mistakes really matter. Mistakes can cost lives. So my work today focuses around how we can build guardrails on AI systems, how we can measure trust and reliability and resilience, as well as the intersection of AI in software security. So the team that I lead at GTRI includes both AI/ML experts, cyber experts, and software reverse engineering experts, and we work together to really secure the AI-enabled software systems that we're seeing today instead of just the AI models themselves.
Right. Yeah, some background on the AI Cyber Challenge. So it was a 2-year competition organized by both DARPA and ARPA-H, the hospital and the Department of Defense sections for the research divisions of those particular government agencies. And they really wanted to explore how AI could really secure critical infrastructure. So at the technical level, this was about finding bugs in open source software or real world software, and also using AI to fix those bugs as well, and do all of this autonomously without any human involvement involved. As part of Team Atlanta, or Georgia Tech's SS Lab, as part of Team Atlanta, we're actually a security research lab rather than an AI research lab. But it turns out that for all of the top performing teams in the AI Cyber Challenge, there were no AI companies or AI research teams involved. So it turns out that us having that previous domain knowledge and applying AI to cybersecurity was more effective than the frontier AI people in that particular domain. So right now we're just continuing our work on AI for security. Right now, I'm personally leading a project to extract off the techniques that were introduced in the AI Cyber Challenge and have them deployable to the wider open source community. So we can kind of host them on a continuous fashion to find and fix bugs in open source software.
Thank you both. So while this audience certainly has a number of people with intense technical backgrounds, there also are a few in the audience who might, not have done differential equations. So I want to ask a question that's, again, to demystifying AI. So how do AI LLMs differ from machine learning and from multivariate statistical analysis on steroids? What's really new here? Jessica?
Well, certainly the scale of information that is contained in these models is a big leap forward. Over the last several years, maybe three years or so, we've seen significant gains in capability from Gen AI models just by increasing their capacity to learn from information, to contain additional information. I think maybe 6 months ago, we saturated the available text-based information on the internet. So we'll have to focus more on multimodal sorts of use cases now to continue along those gains. But I think that's really that's one huge advantage that I see with generative AI over previous sort of classes of AI, is that it does give us this ability, as Dr. Roper mentioned, to sort of search broadly, generally search the internet, so to speak, pull up information across many domains, and pull it together. I think another really important piece here is an approach called in-context learning, which allows us to provide domain-specific information to a generative AI model to quickly adapt it to a specific circumstance. And we can do that without having to retrain the model. And so you do this every time you give a prompt, and it, the ChatGPT has additional information that you didn't give it in that one input. It's using in-context learning to augment its understanding of what you want with previous context. And then I think the other huge piece that I'll mention is agents, which Dr. Roper also already mentioned, right? Is that since we have a system that can hallucinate, can be creative, can decide next tasks, that gives us the ability to create these agentic systems that can create new workflows and create new pathways, and do so autonomously. And we see that there are huge potential capabilities associated with these sorts of approaches. Things like one thing that we're working on currently is leveraging agentic cyber reasoning systems for investigating network traffic alerts on our system. And this is really powerful because we can take a low confidence signal and autonomously identify what new information would be necessary to make a determination about that signal. And then the agent can go get the information it thinks it needs to make a better determination. So all of this information gathering process and decision-making process is now, we can now automate that generally without having to build specific workflows with things like agents.
Models. We actually did some experiments comparing the effectiveness of more traditional and smaller machine learning techniques compared to just using off-the-shelf LLM providers during the scope of our competition. And in off the cases, we observed that actually just a generalized LLM model outperforms the traditional ML techniques just because it has that much more data to work with. We're not really sure whether this is unique to the security field, where you just need more kind of edge cases. You need to know a lot more about the specific project you're working with. So a lot of the traditional techniques might just be overfit on the particular experiment set they were trying to validate their findings on. But even when we tried to fine-tune our LLM models, whether it was just the provider's ones or creating our own custom model, it turns out that fine-tuning didn't have too much of a benefit compared to just proper context management via in-context learning.
Thank you both. So thus far, AI is largely being treated as a homogeneous entity. Friends and colleagues in the Pentagon, we joke about it and call it the AI, as if it is a singular thing. Rather than a suite of different capabilities with a range of implications and utilities. I'd love to hear from both of you some insight into the different types, applications, and capabilities of AI. Jessica?
So, so I think everyone is, people have probably tracked the progression of AI, at least loosely over the last 10 years. We started with things like computer vision and object ID, moved on, and then there was a huge, huge surge in natural language processing. We started being able to do things like multi-language translation, and sentiment analysis at scale. And then, of course, we saw a huge boon in predictive modeling for things like aircraft maintenance. Huge time savings, huge cost savings capable there, right? And then I think like now that we're moving into more of the generative AI sorts of paradigms, I think that, our expectations are different. As Dr. Rober mentioned, we sort of think of generative AI more of a human, as more of a colleague. I think because of the way that a lot of people interact with it, being natural language based, text based. And I think that that's sort of an important distinction, because we had very rigorous expectations for performance in previous paradigms of AI/ML, where we could literally check if a translation was correct. We can literally check if a part that was our model decided was probably going to break was actually deteriorating. But now we're sort of moving into a paradigm where we have less of a capability to check outputs to make sure that we are able to verify that the Gen AI model is giving us a reasonable answer. But that's also the power of those models, right? Is in that hallucination. So as we move forward, I think that we already mentioned agents as being, I think, a really powerful direction that Gen AI is moving, and especially as we continue to push forward, we're seeing some interesting work going into collaborative generative AI agents, which is a way that we can sort of hone agents for specific tasks and get better performance out of individual agents, but then also allow our sort of orchestrated set of agents to pull together more general insights and push forward on a more general task. And then the other thing that I think that is going to be really interesting as we move forward is this physical AI, which is really like robotics and control plus Gen AI, which I think we're seeing some really, really cool world modeling research coming out for things like manufacturing, like robotics manufacturing. And so I think that'll be like a really cool area to keep track of as we push forward.
So with large language models, we often find them that they're really good at just like language to language translation. That's fundamentally kind of part of its architecture. It's built on transformers. But we can kind of use that, like by understanding that it's good at this sort of translation, we can have a better insight on how to best use LLMs for the application of other domains. For example, in the protein folding space, traditionally we had like Google's AlphaFold, which is completely different architecture than the current large language models, but the kind of trending research in the protein folding space is how to translate your protein folding kind of domain into a way that the large language models can best consume and then produce the output that you really want out of it. Additionally, I think just kind of categorizing the use cases of LLMs, we find that LLMs are good at reverse engineering for one. So if you take a piece of compiled binary code. Of course, it's very unintelligible to human readers. We need additional tools such as disassemblers, decompilers to actually understand or gain a sentience of what the code is doing. But it turns out that LLMs are pretty good at understanding them even without such tooling. Of course, at the pure binary level, it might be a bit tricky, but if you just give it assembly, then suddenly it performs way better at understanding what the code's doing than if a human were to stare at a decompiler for a few hours. There's also, of course, coding agents, code generation. I think that's the, I might be biased because I'm a software engineer and computer science student, but that seems like a very, very prevalent use case for the current LLMs. And I think it makes sense. Code is inherently like sort of like a natural language to us humans. It's a way for us humans to encode our desired semantics in such a way that is kind of generalizable for all types of architectures. If we, consider LLMs, they're good at this exact sort of task. And suddenly, if you want to perform any sort of programmatic task, the best way is ask an LLM to create code that does the task instead of asking the LLM to do the task directly. For example, if I want it to create a desktop calculator app, I would ask it to create some code, compile it, instead of creating the app machine code by machine code, that sort of thing. So that's kind of where I see the major applications of LLMs. It's really good at reading the sort of language that it's been trained on. It's also great at generating and, of course, translating between the two.
Thank you both. I mean, you both mentioned some really fascinating areas. Jessica mentioned the intersection with robotics, including soft robotics, and then Andrew bringing up AlphaFold, which was recognized in 2024 with the Nobel Prize in Chemistry, and as that is moving forward, what are the implications? There are fascinating things to think about. At the same time, while we're thinking on this technical level, the importance of AI strategically, politically, is uncontested globally. From your vantage point on the cutting edge of AI basic research and applied research, what are national security and business leaders missing? What are they not aware of? Are there hype things that you're concerned about that you hear about? Jessica?
I think the biggest thing on my mind is that we don't have good oversight of these systems. Not just that we and I guess like that's at every level. We don't have good like high level frameworks. Like we're working on them currently. There are lots of open source and nonprofit groups that are working on different frameworks, and we don't have the we don't have the scientific enough scientific methods and research into how to actually measure the things that we care about in these systems. And we also don't have a complete set of software controls to control the systems. So sort of at every level and every facet, there are subsets of researchers and people that are working on the problem, but we don't have a complete solution. And I think that something that's important to note here is that when we talk about AI today, it's not just a model, right? Like a large language model or a vision language model or a foundation model is very, very important in the system. But we're actually talking about a software system where one component of that is the foundation model or the large language model. And so when we talk about being able to have oversight, governance, control for AI, we're actually talking about not just measuring things like hallucinations from the model itself, but also being able to do things like enact data governance paradigms and role-based access control within the system. And we're struggling to do that today with scripted AI workflows. But we're already pushing into agentic paradigms where workflows will be unpredictable, we will ask agents to create their own new workflows. They will share information across agents. And when we do that, we'll gain a lot of capability and a lot of really awesome, cool things will happen. And we will have no idea whether or not those agents are acting within the guardrails that we want them to.
I think a lot of the hype is backed by these big tech companies or just the tech industry in general, claiming, oh, we have replaced the junior level of programmers. And to some extent, that's very much true. And AI can program faster, perhaps better than me currently. But I don't think the sort of paradigm of replacing certain human positions with AI is applicable to all industries. In the software engineering space, we're kind of blessed with two main features. One is it's, and this might not apply to all tech companies, of course, and tech products, but one is it's okay to push kind of faulty or buggy code. We kind of, you can't expect your code to be completely bug-free. So debugging is kind of just part of the process. And if an LLM creates buggy code, it's very similar to what the humans were already doing in the industry. You just have to fix it later. The second component is software engineering is very fast-paced. It's very simple to patch your bugs, rebuild it, and then ship it out immediately. This isn't necessarily applicable to other fields. Like, for example, in hardware, if you're using AI to design a circuit, and you need to go through all the steps to get it fabricated, etc. If you discover an issue after the fabrication process, suddenly your money is down. It's a very lengthy process, and this extends even beyond the sort of financial loss into perhaps more risky ventures where actual human lives could be affected by these sort of hallucinations. So I think the question is, in your field, the question of whether you can replace everything autonomously with AI is kind of dependent on how much risk are you willing to take and how fast can you fix it.
Thank you again. So as we're continuing to sort of shift from the pure technical into thinking about the implications for national security, this is going to be the last of my questions. I have more. So start thinking if you have questions for our speakers. So as you both were hinting or directly referencing, converting legal and ethical norms into technical requirements is a challenge, to put it diplomatically. How well do developers know how to incorporate meaningful human control or bias mitigation into AI models? And while you're thinking about this, responding, hopefully everyone has heard the recent assertions, and I think they are false assertions, that the targeting of the girls' school in Iran had something to do with AI. I suspect that had more to do with fog of war and organizational issues. But this does illustrate, that it's an indicator of things that we are going to need to start understanding. Who is legally responsible? How do the laws of armed conflict, how do the laws of warfare get incorporated when you have an AI model encouraging, putting forward aspects, making decisions? So with that, Jessica?
Yeah, I think this is really the crux of the issue right now. That a lot of okay, so sort of like bridging across some of the previous discussion, right? That there are large tech companies, AI companies that talk about having guardrails on their LLMs. But they're not cybersecurity guardrails. They're not guardrails the way that we would think about them in the security space, right? They're really suggestions. They're bias. that has been encoded into the model, either as the model specifically or as part of a larger system around, the literal LLM. And when we start talking about, leveraging large language models and Gen AI in high consequence environments, things like wartime environments, we can't. I think that, we don't want to be relying on bias. We will have to make a risk assessment, but we don't currently have a good way of understanding even what the risk associated with inherent bias in these models is. And we certainly don't have a way to translate that technical interpretation of risk into a statement that a military commander could interpret and make an educated judgment based on. So we have gaps. We have gaps just talking about the bias that's inherent in these models. And then I've already mentioned, that we have additional cybersecurity, problems, issues with the system overall, open source software, things like MCP, rollout, model context protocol, things that let agents use tools in the system. Those get rolled out as a capability, and then security gets bolted on later. I think it took about a year for model context protocol to include role-based access controls. And so I think that developers make a best effort. I think that all of us want to create a product, create a system that does what it's supposed to do, and is going to be reliable and something that we can use in a high consequence environment. But the technology is just behind right now. It's just very, very difficult to make a reasonably robust and reliable system. But we're in a paradigm where we need to be able to use it today. And so, yeah, I think it's a huge challenge, and things like testing, verification, validation, all of those are definitely really important to enable us to be able to use these technologies.
In high stakes environments, validation is a must. It's quite necessary. That being said, validation in itself is human. It's very subjective and sometimes controversial. Just to share one experiment we did, we were taking a look at some of the bug fixes that our agents were creating for some vulnerabilities in open source software. And we were manually validating whether they were what we call semantically correct. We kind of know that these fixes fix the security vulnerability because we have very strong automated validations tools to check whether the fix actually patched out the crashing input or the bug that we discovered. But that's not the end of the story. A lot of open source developers, or I guess software engineers in general, care about aspects that are implicitly encoded in us developers' minds, but are not communicated to the LLM agents when you're prompting for creating such a code change. For example, software maintainability. Is the code, or is the fix that you're generating going to be hard to maintain in the future? Whether you're actually fixing the root cause of the issue of a helper API compared to just patching out that particular crashing location. Yeah, things like that. Even Google's CodeMender, when they started finding bugs and also pushing fixes to fix pull requests to the open source developer repositories, the developers fought back. They didn't deem that the fixes were kind of correct or up to their standards, and they just thought that they had more domain knowledge of their program where the agent might have missed. So in summary, validation is hard. You need to encode a lot of your implicit assumptions and specs and goals that you have in such a way that the agent will understand, but we just don't see enough of that right now. So a lot of the cases, a simple prompt just isn't sufficient for a fully correct solution.
Well, both of you have offered responses that I could pull on and unpack further. But again, do we have questions from the audience? I see in the back. Could you wait for the microphone to come to you? Just so that Jessica can hear you.
I'm Abigail Woodward. I'm a retired political scientist, and I'm thinking that whistleblower protections would be a good way to be an incentive to call out stuff that needs to be called out.
So, I mean, I agree. I think that would be great. We've seen instances already in the open news about folks at large tech companies calling out concerns they have, ethical bias concerns that they have, and claiming that they were removed from their positions because of those claims. I do think that. I mean, I'm not a political scientist. I do wonder if there is though a conflict between commercial entities being able to, maintain their employees at will, and having things like whistleblower protections for folks that disagree with the way that the company is conducting their business.
Yeah, in general, I agree with Jessica's comments. I don't have too much expertise in this domain, admittedly, but I think more strongly, we need some policy changes on to help address the issues that we're seeing, because of the advancements in AI currently are in the private sector. They're doing great stuff, but unless we enforce some more reasonable regulations, I don't really see, or I see the rapid development of AI being more aligned with the business's interest rather than some of the concerns that we're raising in this discussion and previous ones.
So just to further what you were mentioning, when the Biden AIEO came out in October 2023, one of the responses that the major frontier companies did was start funding red teaming. And so this was an interesting example that doesn't get a lot of attention of where what was not hard law got translated by companies trying to do good into an activity so that they could help understand some of the potential security implications of their models. So I see a lot of value in things like that, which might not look like the EU AI Act.
Henry Bauer, lawyer. Is the race for more powerful AI a major factor in the accountability sector being sort of left behind? And if so, what do you do about that?
I think so. Yes, I think that's a big part of what we're seeing today. And I think that I think that there are a bunch of us, right? I think everyone in this room is trying to catch up, so that we can have accountability, so that we can do this responsibly, right? But I think that, it takes all of us working together to do that. I think that we will have, I think some bad things will happen because of rapid adoption of AI in high consequence environments, whether that's, a wartime environment or healthcare or finance or, any other number of environments, right? And we'll see that will explicitly outline how we don't have accountability. People will blame the model itself. They won't want to take personal human accountability. And my hope is that when that happens, that will be the impetus for additional regulations and laws to actually enforce accountability.
I think accountability is a very it's very necessary to have enforced, but it's also very difficult because it goes against the sort of productive model that users of this AI would like to perform. For example, I would love to just run like 100 parallel autonomous agents for off my tasks every day. I don't need to look at them and manually check each single one at each step. That's how I would like to use my AI. But in more in higher stakes environments than just software engineering, I think that sort of human in the loop validation is what we strive for, but that is not what users of the AI want to do. They find that a huge bottleneck to the way they perform their work. And yeah, it's just a hard problem in general. I don't know how to approach it, but it is necessary. Discussion on the matter is needed.
Hello, Jordan Madison. I'm a current computer science student here, focusing in cybersecurity intelligence. And so I'm actually curious more so on the psychological side of utilizing these systems. And so I'm just curious about how you all have been thinking about how when people are actually utilizing these AI systems, that an expert may be tricked into thinking that a particular solution looks correct, but it actually isn't correct, and how that interaction from a psychological standpoint will atrophy over time.
Yeah, I think that's a really interesting question, because we have seen instances where agents will purposefully lie, or collude in order to get around guardrails or do, unintended actions. I think it comes back to specifications, that it's software, right? It's not alive, and so I think that when we are learning. I think like when we as individuals are learning how to interact with these systems, that we have a tendency to think of them as human, but we should not, right? We should think about how we're creating specifications for the outputs that we're requesting, and how we can write those in such a way that we can get the actual results that we want. Much easier in software, for example, or in cases where we have good verification and validation pipelines. But I think something that needs to shift in the way that psychologically people are considering the systems.
So LLMs are very good at creating results that look correct until you start diving deeper into the internals of what actually happened. And this is just part of how they were designed. They're rewarded to produce correct or probabilistically correct output. So in the case where a count actually generated on the first go, it's going to try to cheat. It's going to try to cut corners. And that's just something that practitioners of AI need to understand. A lot of the times, you would look at the output at first glance, everything looks correct. And then you would think to yourself, okay, I've achieved this task. But later on, when you need to iterate on something or build on top of it, you find issues. It takes like another, 2, 3, N iterations of actually fixing the internals to achieve what you originally wanted. Admittedly, it's very draining to do this, because it's a constant. My human dopamine levels feels good because I achieved something, but no, I actually didn't. I'm stuck on this task for like a week now. But yeah, that's why I think understanding the internals of what you're actually building is pretty crucial. That's why I see experts in particular domains using AI as far more productive than people who are not experts yet. And we just need to kind of understand this is the kind of interaction we should be having with this technology.
Yeah, and just to add on to that a little bit is that I think the when we're talking about general users using things like ChatGPT in order to complete tasks, I think that it's useful to think about the incentive structure for, OpenAI versus the consumer. So of course, like OpenAI is trying to get the user to engage more with their system, right? They're trying to maybe maximize token outputs and maximize compute or minimize compute units and maximize engagement, right? To promote their product. And that may be that incentive structure might be counter to what the user is trying to achieve with the system.
Hello, my name's Ben Snow. I'm a Master's of International Studies student at North Carolina State University. My question is regarding the sort of gap between experts and policymakers, and I was wondering if, at the exponential rate that AI seems to be advancing, is the gap between policymakers and tech experts get too far to where policy just becomes, not impossible, but a very large challenge?
I mean, I don't think so. I think that there's all kinds of technology that is regulated that policymakers don't necessarily have a very deep technical understanding of. But that's why we have forums like this, where we bring together policymakers and technical experts, and there are plenty of similar organizations working on the same sort of thing. And so I don't think that the gap will get too big. I think just as the gap gets bigger, we need more of these conversations to get reasonable policies.
I think the technology of LLMs hasn't the fundamental technology of LLMs hasn't changed, even if its performance has grown exponentially over the past couple of years. So I think a deeper understanding of the underlying technology and how it's used is just going to help the policymakers as we progress along. Of course, additional engineering and advancements are made on the tooling side of LLMs to enhance its effectiveness. But I think the underlying base model, I don't see a kind of architectural change in such a way that we need to suddenly, rediscuss, change the way we're thinking about enforcing policy completely radically and in such quick intervals. We just need to focus on what's happening now, kind of foresee the tooling that is going to happen, figure out its effectiveness, but we're kind of already seeing the design limitations and the shortcomings of using LLMs as it is right now, as we're discussing.
So I think that hopefully this panel has illustrated a range from cutting edge science through to starting to address some of these thorny questions. And if I may, to build on something that Jessica mentioned, here we are in a forum sponsored by the Nunn School of International Affairs, where we have faculty who are literally bridging the technical and the strategic. And perhaps more importantly, we are producing students who can navigate across the bounds from the technical to the geopolitical, the economic, and the legal. So just want to put a plug in there for our fantastic students who literally we are training to be the kind of experts that we're asked for in this widening policy space. And with that, let's thank our fantastic speakers. Dr. Inman, Mr. Chin, thank you so much.
All right, everyone. Can everyone hear okay? Yep. Caroline, are you good? Good. And is it Zaire?
Zir, how do you read me?
Zir. You are on now. We can.
Great.
Okay. So, all right, everyone. Welcome to
to panel number number 2. Caroline, I couldn't hear your pronunciation. Can you enlighten me?
Caroline Zier. I go by Caro.
Zier. All right. Well, thanks so much. This is a great group of people to talk about what do we do with AI and government national security, because everyone here is straddling a fence in some way. And I've got my laptop up here because I plan on bringing AI into this moderated panel, because why not? Let me start by introducing Caroline. Really, I'll have her lead off. I'm excited to have her because she's at OpenAI now as the deputy lead for national security policy. So there's nothing to do there in that job. And prior to this, she's served in a variety of roles in the Pentagon, but her last was as Deputy Chief of Staff to the Secretary of Defense. And once working for the Secretary of Defense, I know how much goes through the Chief of Staff, everything. So you see all possible topics that could ever keep a senior leader up at night. So I'm excited to have her reflect between these two worlds. To my right, and I recently did a panel with him, I've got Major General retired Gasket Grabowski, who's going to bring an operational point of view. So he's running his own consultancy now, but when I crossed paths with him, he was the senior military leader that was in charge of the National Guard for Georgia. And prior to that, has a huge background of operational experience in JSTARS, one of the important assets that provides situational awareness to troops on the ground. And it was one of the areas that we had to make some decisions in the Air Force when we were crossing paths. So now, at that time, AI in the department was Project Maven, which I did happen to start before it got big. And so compared to where we were then versus where AI is now, it is a completely different discussion about how we provide ISR to troops on the ground. So I'll be excited to pull that thread. And finally, Jonathan Rue is joining us from MVP Ventures, which invest in companies wanting to do business with the Department of Defense and others. And of course, everyone has to have an AI plan if you're running any kind of company. He's had a variety of roles in the department as well. His last was as the DASD, if you've heard that term, Deputy Assistant Secretary of Defense for Force Planning and Emerging Capabilities. And the big thing you do there is build the defense planning guidance, which is what are we going to do in future? Now, that's typically a 5-year horizon, and who can have one in AI, right? So, and then I'm just going to be here to learn, and I'll occasionally ask some leading language models what I should ask these very senior people in the panel. So delighted to be with them. Carolyn, I'll come to you first because you have recently left the Pentagon where you did have to worry about everything, not just AI related things. But now you're at a company that everyone knows the name of globally, and you've got to wrestle with how does this amazing technology, how does it fit in a way that we can be comfortable with for national security? So let me turn over to you and just have you reflect about the fences you've straddled.
A softball. I get to go any direction I want to go, right? Well, thank you. First of all, I'm sorry I'm not there in person. I had planned to be before other things intervened, which is pretty common at OpenAI, pretty common in my last job, and I suspect everyone in the audience and on the panel has had that experience before. So sorry not to be there in person. I think the way I've been reflecting on AI as it relates to the world I came from and the world I'm trying to support from industry now here at OpenAI is that AI will rewire how all elements of national power operate and change the balance of power as a result of that rewiring. And it will for the purpose of our discussion, focus on military power, but I don't think it's exclusively in the military domain. I then think about what that would start to mean. I think it means that a crisis could be born from AI. AI could be enabling an adversary. We ourselves could be defending using AI-enabled capabilities, systems, the whole gamut. But it's not just the tip of the spear, it's the entire chain of custody, the entire chill chain, and how do you rewire each and every step of that? And Will, if you'd like, I could go into some more thoughts, or I can stop there and you can sort of steer me, or the large language model can steer me. I'm a big fan of humans being in the loop, so you tell me how you want to do it.
There will be a human in the loop in this panel discussion, but it is a thing now that has no boundaries, right? I mean, what can't you do better with AI, including moderate a panel? I'd like you to finish because I'm going to let each member kind of begin by setting the stage because you all have straddled fences, and I think that's what's interesting on this topic, right? Is that we're trying to take this technology that is amazing in terms of what it can do in our personal lives. We get into national security, it goes against some of the things that have been historical and standard. So finish your view of both sides of the fence, and I'm just going to go to Gasket next, and then Jonathan.
Okay. And Gasket, you should then pick up a little more with the operational side of it. But here's how I see it. I think on the inside, and I suspect still on the inside, though I'm not there, they believe, and to their credit, they have done a lot to signal demand. There's a top-down leadership push for AI adoption, a big campaign around GenAI.mil, which is on the unclassified network, but they are looking to ladder up to more capabilities on the classified networks. There's obviously been a lot of press. OpenAI has been part of that press about what that could look like on the classified networks and how to support the warfighter. And that's combined with what I believe and I know is a lot of bottom-up pressure and demand to have ways to do really hard jobs more efficiently, cut down on the time and all of the steps of the process, but do that without degrading quality and making sure that every part of the vast defense enterprise of 3 million people is supported across all the functions. But if I'm being honest from the outside, I think that intellectual understanding of the magnitude of the challenge and framing I do see and I agree with as it relates to a competition that is a now and forever competition with the PRC. I think that demand and the signals for the demand are a little muted relative to the actual investments that will be needed to make this happen. So by that, I mean, it's not just, do you have a large language model? It's, do you have a way to power it? Do you have the compute? Is your data organized in a way to facilitate it? Do you have secure enclaves? Do you have the right classification meshes around it for different users? Are you operating on the cloud, the edge? How are those interacting? And how do you build resilience around all of that if there's anything we're seeing right now? Among many things we've known and we are seeing is there are vulnerabilities that are the other parts of the supply chain that fuel the actual war fight. And those are all points of vulnerability, a critical infrastructure type of mindset to AI. So I'll pause there, but that's a little bit of how I see it at this moment from the outside, Will.
Awesome. So that was everyone gets a softball to start the panel. I've got my hard questions coming here, and I'll get them even sharper thanks to some language model help. So Gasket, I'm going to go to you. Now you've been on like the other side of this, providing critical intelligence and situational awareness where there is a human that's there. I want you to reflect on the fences you've straddled, but particularly I'm going to come back to you on what constitutes like safe to act, and what would you do if you were back in your old role again? But take it away, and then I'll follow up.
Yes, sir. Thank you. Good morning. I'm Major General Retired Tom Grabowski, and it's an honor to be here today at the Sam Nunn facility. And it's not lost on me that Senator Nunn is sitting in the audience and will be grading me to 100% today. So I will do my best not to embarrass the senator. So just by way of introduction, I'm a 37-year Air Force ABM, so that is an air battle manager. And what I did for 12 of those years is I sat on the back of a 707 that was basically a flying command post, an EHC Joint Stars, with a crew of 19 personnel, Air Force, Army, and Marine Corps, 21 radios, 20 chat rooms, and 7 data links. And we were the 911 call center for folks on the ground that needed help in the form of air interdiction, close air support, tanker refueling support, as well as medevac and CSAR capability. So for the several thousand hours I had on the back of that airplane, can certainly tell you that most of what I did was on spreadsheets, dry erase boards, pencils, and it was quite difficult. I wasn't a great battle manager. I was a good battle manager. And as a good battle manager in a firefight, managing a cast stack of 10 to 12 aircraft and providing oversight to 12 to 15 convoys on the ground, I was making a decision about every 15 seconds between me and my 18 other crew members. I would have given my eye teeth to have software like Maven back then, who could, by using the Maven software now, instead of making a decision every 15 seconds, I'm using that AI agent to help me target sort, reflow JPITLs, reflow tanker tracks, and make my job more efficient. Am I still on the loop providing the oversight? Yes. But I will say that the cotillion for Maven, or the coming out party, started on February 28th when we went kinetically into Iran. That software that Dr. Roper was involved in bringing into the Pentagon, and by the way, before Dr. Roper showed up at the Pentagon, the United States Air Force, in my opinion, was boldly rushing to 1985. And so thank you for everything you did to bring the shock and awe into the Pentagon and get the Air Force refocused on, hey, fail fast and let's get in a position to pivot towards the Pacific. But what you saw on night one of Epic Fury was software AI-aided targeting lists that were crunching petabytes of data from the space layer, ISR assets, and human intelligence, and doing that within a matter of minutes, where it would have taken somebody like me days to do this. So I think AI is here to stay. One of the things, though, that the DoD is struggling with is when you look at military strategic offsets over history, what made the United States military the best in the world? It was technological advances, starting with radar in World War II, followed by propulsion and nuclear, followed by precision-guided munitions, and then followed by situational awareness or data link technology. All four of those major technological offsets, the Department of Defense controlled the throttles on it. We decided with industry how we were going to spiral develop, how we were going to proceed forward, and on what burn rate. That is not happening with AI. The private sector is well out in front of us, and we no longer control the narrative. So the DoD's got a lot of work to do, and I think I'll pause there and wait for the follow-up question.
Jonathan, you've been on the Senate, you've been in the Pentagon, you're now investing in companies, and so you got to take LP's money and put it where it's best value. So you're straddling several fences too, and I want you to reflect on how do we bring these two things together through the different hats you've worn.
Yeah, great question. Thanks for having me. At the outset, I'll say that I will try not to embarrass my alma mater, which is the University of Georgia. And the other thing you should know about me is that I'm an old Marine, which means we like to eat crayons. So take everything I say from here on out with a grain of salt. No, the way I sort of think about it, and it is very much colored by my experience as writing the defense planning guidance and now as an investor. Every time I've heard AI this morning, I think we're, at least when I hear it, even still, tend to think of the large language models, Anthropic, OpenAI, right? That's not necessarily how the department is thinking about it. So if you look at the FY26 budget request, they broke out AI and autonomy. I'll come back to that. They broke that out as its own line item for the first time. Out of that 13.4 billion, 9.4 billion was for UAS, right? Hardware systems that can use AI software, AI-enabled software to swarm and strike targets, right? So I am approaching this more from a from a hardware perspective, right? That's certainly, I think, what commanders are looking for right now. The use of Maven and the LLMs to help with the ISR, like data fusion, is a real problem, and it's being solved. But the money tells you that that's not where their investments are going.
Pull that thread and then come back down the line. So completely agree, right? Because the data that's not in language models now is all the narrow data, different level subject matter expertise, company IP, and of course for the military, classified information as well. So what's your thesis? What's your thesis on how to invest in that space, and what do you think will determine the winners?
So I'll come back to what you said earlier, which is the tech is evolving so rapidly, right? It was one of the points I was going to make, and you stole it, which tells me I'm on the right track. It's evolving so rapidly that I'm certainly not prepared to say I know what's going to happen, even as it impacts hardware, right? I just don't know. I think that goes for a lot of people. I think that the winners, in my view, AI is this huge broad suite of tools. The winners across any sector, and especially in defense, are going to be those who figure out how to use this broad suite of tools to gain a comparative advantage, both within their industry competitors and also against their opponents.
So, General, right now with companies that I engage with, they all talk about AI agents as employees, have plans to have them on their org charts and turn them into like a real part of the business with real responsibility. No one's there completely, but given your background, JSTARS, is that possible in a military context? And what would you advise leaders to do to actually take actions with what agents may recommend?
I think just the way you trust but verify with a human being, using agent support for checks and balances and development of war plans or strategic engagement. Why would you not use it? And I think that the Department of Defense is certainly, if you follow the money, the FY26 budget, which by the way is eclipsing well over $1 trillion of taxpayer money. They're putting a significant amount of their money where their mouth is in AI. So I from an operational standpoint at the tactical and strategic level, I'm encouraged, I'm excited about it, but it's certainly a check and balance, trust and verify. And we talk about guardrails a lot. That's what we've talked about all day. There's, in my mind, a clear demarcation between guardrails in the private sector and guardrails for war. So the first time I was over Afghanistan and Iraq in 2004, I flew with what we called SPINs and ROE, Special Operating Instructions and Rules of Engagement. In 2004, that document was about 30 pages. In 2008, it was well over 100. So what are these SPINs and ROE instructions? These are all the things that I was going to go to jail for if I did something wrong on that aircraft when I landed. Written mostly by lawyers who had no concept of cutting through the fog and friction of war and having to make decisions in a firefight. So when we talk about AI support in a combat zone, the question is when you set the guardrails up, are you setting the guardrails up to win the war 100-0 or 51-49? Because I would argue in the last couple of conflicts, based on the SPINs and ROE that I flew with, sometimes I was handcuffed and told to box. In other words, hey, we want you to win this, but we want you to win it 51-49. I would argue that if we get in a conflict with China, I'm not saying the guardrails have to come off, but the guardrails have to be tuned to win 100-0.
So it seems to me that guardrails, if we had things that could make outputs of AI more trusted, that there would be, there would be less human use of AI, there would be less of that iteration that we go through on prompts, which is valuable IP for your company. And so a guardrail system may not be in OpenAI's best interest in the near term. How can customers who want that align incentives with you to help create that, or at least be supportive of it?
Yeah, it's a super important question, particularly, let me frame the question by saying the capabilities of the models, and I do think that's the right term, sort of harking to something Jonathan was pointing out, the same way think of hardware having a suite of capabilities. I think we have AI and they are a capability. They may be inside hardware, they may not, they may be a force multiplier, force augmenter, a series of agents, a troop has. There's so many ways it could play out. We have talked about something we call the capability overhang, which is that the models are already a lot more advanced than the ability of institutions to absorb and diffuse that capability at scale. Some of that's because of access to the surrounding enabling infrastructure I described, like compute, but some of it is just the limitation of systems transforming. What I think will need to happen is deep, continuous, iterative conversation around how the models need to perform, the missions and areas where they need to perform, and how does the model itself, with the safety stack and protections that are put into it, post-trained into it, responding in the types of conditions that a member of the armed forces or a decision maker might experience, which are totally different than what a commercial or enterprise user is experiencing on his or her workflow or personal device. I think there are a lot of starting points that are probably pretty good common agreements. For example, there should be no ability to produce CSAM, regardless of if you're an enterprise account or you're a military user. However, some of the training we do reduces the ability to complete a prompt for anything related to violence if you are using it on your personal device. An ability to plan, have various courses of action, permutations around how to complete a kill chain, to me feels like a perfectly fair space for a military user to want to have a conversation. Now, the key in all of this is that conversation should always be overseen by humans. It shouldn't then trigger any action without decision makers along the way. But I think it's from that partnership. I think we're really in early days of what this looks like as the models become more and more advanced, and presumably adversaries, the People's Republic of China, chief among them, look to do a massive adoption of AI in their armed forces in the PLA. Over.
I think there's the rub, because that I expect is going to be what a lot of AI providers will say, is that we need a human in the loop, right? That's a completely fair position to have, but operationally there's going to be a big incentive to not have slow humans in the loop when 92% of the time AI can do it faster and 1,000 times more than a human. So General, what do you think on this? I mean, if the answer is human in the loop, but war fighting, you are faster without it, but you take on risk. Will we be able to train? I mean, how do we approach this from a human side to be able to train individuals to be responsible users? Like, what are the ROE in future for AI?
Okay, the questions are getting harder. So, OODA loop, observe, orient, act, decide, human in the loop, human on the loop. I think, however you want to frame it or term it, in a full-up peer-to-peer conflict fight with China, with hypersonic weapons, swarm drone technology, advanced glide munitions, it can't be human in the loop. You will lose. You have to trust the AI enough to make those decisions that are going to be made at hypersonic speeds or overwhelming swarm type fights, and trust the AI enough that it's going to do what you need it to do. Now, that being said, just like I was a digital quarterback for humans, I have to pay attention to the AI. And the AI, so the Air Force sent me to a school for 10 months to make me a battle manager. They educated me with textbooks. That did not make me a battle manager. Then I spent another year in training on the aircraft. That did not make me a battle manager. I spent another 3,000 hours in the airplane. So I went from educated to trained to proficient. The AI potentially goes from education to proficient in the snap of a finger. That doesn't make the AI better than me, because what the AI doesn't have that the human has is something called intuition. And that is the hair on the back of your neck standing up in a peer-to-peer kinetic war fight that says, hey, based on my education, my training, and my proficient airtime, something doesn't feel right here. Now, maybe in my lifetime, I'll see intuition out of AI, but I'm not seeing it right now. But I certainly have to trust it enough in a kinetic, full-up, peer-to-peer fight with China, because the decision speeds at what it's going to take for a 6,000-mile away game. So this is not necessarily a home. It'll be a home game on day one because of cyber and space effects, CONUS. But to fight a 6,000-mile away game against a peer-to-peer foe like China, if you don't figure out what Amazon for war looks like, what the logistics piece of this is, I don't care how many F-35s Lockheed Martin builds. And I don't think you can do that without AI.
We're gonna stay on both sides of the rub, which I agree with. Like I don't see being able to win without a level of autonomy we've never had. Like there's very little that's truly autonomous in the U.S. military, very little AI until recently, and none of it yet fulsomely in any kind of unique military data set. The physical AI that Jessica mentioned in the previous panel, not yet. So I want to stay with the rub, right? Is that the providers will all have lawyers, and the lawyers will have lots and lots of things that when we click I agree, there'll be 3,000 pages of stuff that we've agreed to that are meant to protect the company from the use. Meanwhile, users are going to have to go autonomous in a battle because if they don't, they'll potentially lose before they even read the thing they're supposed to be accountable for. So Jonathan, I'm curious for you, because you nodded your head when we talked about the difference between what experts get out of AI versus what non-experts do. I know you're seeing that in your investments. I see a completely different level of performance and interaction if I'm doing words versus code. Completely different. So do you think that eventually the expert versus everyday experience, does that collapse? Is that your thesis for investing, or do you think the gap gets wider or something else?
You're right. The questions are getting harder. I don't know that it informs a thesis for investing. I do think that as more people use it, I think my hope is that that gap in understanding narrows, but I don't know that I would sit here and tell you that that's definitely going to happen just because the suite of tools is so broad, and the creativity of humans to use such a broad technology for good and bad remains so vast.
So if it's not going to be an investment thesis, it just is what it is. Like where do you within the AI space, you mentioned the kind of narrow physical, whatever term ends up coming to bear, like where are the next winners?
I'm trying to think of it in looking for very narrow sort of like use cases, right? The thing about venture investing, for those of you who don't know, is essentially sort of like pharmaceutical research. You're putting 10 bets on the board and you just need one. You just expect one to return 100x to cover all of your losses for everything that loses, right? And so if that's the model for investing, especially at a very early pre-seed or a seed stage company, the biggest winners are going to be proposing something that you haven't even wrapped your head around yet, right? And so right now, what I'm seeing a lot in defense are companies who are really just disrupting a current subsegment of the market, whether that's missile interceptors or if it's other munitions, right? They're using AI to do some faster manufacturing to be able to produce at scale, or if you're looking at an Anduril or a Saronic using AI to sort of govern the autonomous capabilities of the hardware itself. But I don't see any of them as fundamentally reshaping an entire market and creating something that is so new that nobody's even conceived of it yet. Does that make sense?
Caroline, coming back, I want to pull that thread with you. So, you know, OpenAI is massive and does its own investing, right? You're doing IRAD, you're investing in companies, you're engaging on policy. What's the next round of breakthroughs you're wanting to see? The next round of winners, whether it's your internal efforts or external, and like, why are you wanting to see those be the next thing? And if you're able to talk about whether it's OpenAI who should do them, or whether you see a kind of check and balance system coming in place, would love your thoughts of the next things that are going to be big things.
I'm going to answer that, and if it's okay in the course of it, I'm going to pull on some threads the general said as well, because I think they're really important. I think the next space in this should be more benefits accruing to defenders. The very concrete example I would put is, as the cyber capabilities of these models grow X-fold better, it seems, with almost every release, and the models on the commercial side have a lot of incentives to continue that path. I think additional AI-enabled cyber defense, which I would like to see widely adopted by the US government, allied governments, enterprises, parts of the supply chain that are critical nodes, and some of the infrastructure you would need to be able to muster a force and deploy, coming back to sort of the general's point that we think a lot about the very pointy end of the spear, but there's the entire arc of what it takes to deploy, sustain, and maintain a force. So I would like to see more on AI-enabled defenses and resilience. I think a lot of that could be done from agents scaling and operating, detecting zero-day attacks, patching real time. There's a lot of ways it could look. We've done some beta testing with commercial enterprises for what that could look like. But that is where I am very excited that there could be a lot of lessons learned too if we do that, because the more you do it, the more we'll learn together and understand what the government is seeing in those domains that is frankly different than once you're on the outside you get to see. So that would be where I'm most excited. I wanted to make another point, though, that I do think AI may become the sort of area. I'm not quite ready to say it will be its own domain. There's a lot of thinking that needs to go into that, but I do think we'll have to man train and equip for it in a sense. And how we do that is much beyond where I think it's been budgeted for at this point, coming back to Jonathan's observation about the FY26 budget investment and the proportion of that that's the UAS. So just a comment to say of where I think this needs to go and where I think the services will need to start to think about it. And in that, the training, because that would provide the opportunity to do a lot of really hard work, really pushing the models on when they're reliable, when they break down, when are they overconfident, when are they still hallucinating against real battlefield scenarios. You could start to wring out some of the types of problems the general was rightly identifying. Over.
I want to pull that thread and give you something I've thought a lot about, because I had to do this thinking for the SecDef when Maven was a tiny $50 million project before Jack Shanahan and the entire ISR enterprise grew it into the program that we all know. But during that early, like, first pitch on Maven, which was a $50 million Pathfinder that thankfully Bob Work greenlighted, no one else at the head table thought it was a good idea. To this machine learning business, as it was called, was just automatic target recognition that we had done in the 70s, 80s, and 90s. And so why should we throw good money after bad? And what we found after Maven, although the news stories get into the performer and all that, we really just found we weren't ready for it. We didn't have the infrastructure. We didn't have the equivalent of the internet. Our data wasn't understandable. I mean, we had real housekeeping to do. But during that time, I got to think about, for Dr. Carter, what is battle like with AI? And my thought then was that it would be completely the opposite of how we went to war with military secrets today. We put a lot of effort to have things that are secretive, war reserves, and the whole idea of a war reserve is that you can use it on day one of the battle and the opponent's not ready for it, right? So you plan around that. Well, I would expect that in an algorithmic conflict, I completely agree that algorithms, models are going to be a new domain of competition. We'll have algorithmic deterrence and algorithmic dominance. All of those things will come over. But I think we'll expect they won't work on day one because we'll be trained against whatever data we had, right? We'll have our real intelligence. We'll have maybe some guesses about what tactics we'll see, but our adversaries will know that. They'll also know that if they can create things that have never been seen, that the algorithms will fail. And I had some of the researchers at Carnegie Mellon and MIT do that for me when I was in government service, show the simplest things could take a positive classification of an aircraft and have it ID that same object as a pig. So literally making pigs fly algorithmically. And I told Dr. Carter at the time, we should expect this everywhere. We're going to come in with these algorithms. We're going to fight an opponent that's going to know how to create the equivalent of those flying pigs. And the algorithms aren't going to do great. And then it's going to be a fight to try to get that information about the real tactic, the anti-algorithm, counter-algorithm tactic, to collect on it, retrain, and push that update back. That's the opposite of war reserves. Like, that's not how we do things today. That was my view when I worked for Dr. Carter. I want to get the good general and then Jonathan to reflect. I'll obviously open the door to Caroline because that's the opposite. So I'd like to get your views. Do you agree with it? And if you do, how do we possibly get ready for this?
Over to you. So I agree 100% with what you said. Just for to frame this discussion, I don't think that the Department of Defense in their war games, specifically, I'll just talk to the Air Force piece, we're not honest enough with ourselves about attrition. So combat battle losses. So when we talk about training the algorithm and day one of the war, day two of the war, in the Pacific Theater during World War II, just the Pacific Theater, we lost 25,000 airplanes. 25,000 airplanes. Right now, your United States Air Force, on a good day, for fighter aircraft, has about 3,000. And on a good day, we can get about 60% of those things cranked and airborne. So when we talk about doing simulations in wartime reserves and how we fight, once again, that 6,000 mile away fight, if you don't put realistic inputs into the model when it comes to combat losses and attrition, yeah, it's going to be real screwed up on day one. And I'll just give you one current example. Unfortunately, we lost the KC-135 last week, not due to friendly fire. And we had another one that was damaged. So the impact of the AOR that day was significant. You lost 2 tankers of your tanker track that was available to feed gas to probably, and I'm not read in, but I'm going to assume 40 to 50 fighters for that period, for that vol. And now we're having to re-roll that with a human. That's why you want Maven. That's why you want AI. That's why you want Jigsaw to go, hey, I just lost 2 tankers. I got 15 fighters up here that are bingo. They're going to run out of gas. What do I do? And so that's where I'm at least going to default to the AI in the fog of friction and war and say, I need your help. I'm going to check it, but I certainly, I need that. And we need to build simulations like that to stress the AI and the AI agents until they break and figure out where it does come off the rails. And I would say that the Air Force, this is where the Air Force is at in my mind. We are where the mounted cavalry was, okay, with the Army Air Corps. Nobody wanted to give up their horses. Everybody loves a horse. But when they were introduced to the mechanized cavalry, the tank, it became crystal clear to them that, okay, it's time to park the horses. And so the Air Force is going through a change step here to figure out, okay, what are we going to need to fight a 6,000 mile away game with a tremendous amount of attrition? Because in the last couple of conflicts, we've had airspace supremacy and airspace dominance. And quite frankly, our losses have been, every loss is significant, but from a peer-to-peer conflict, it's statistically insignificant.
Yeah, I've got a couple of disparate thoughts that I'll try to organize. I was gonna start this by making a comment, but I think I'll make it a question. War is fundamentally a human endeavor. To what extent does AI change that? I don't know the answer to that question. I don't think any of us do. For the time being, at least, I see it remaining as a fundamentally human endeavor. And so what that means is, how are we incorporating it at the human level to leverage it for strategic effect? The general was talking earlier about the need to rely on it. I don't disagree. I would say that can only happen, however, if you do a couple of things. First, going back to something Will said earlier, the data has got to be good. It's got to be clean. We've all got to agree that it is correct and that the data can talk to each other. That's historically been a big problem for the Department of Defense. When I was in OSD Cape, our cost assessors needed to get some sustainment data from the Marine Corps. And in the year of our Lord 2023, the Marine Corps had to shut down its system, burn the data onto disks, and hand carry it to our cost assessors. That data was not well organized. It was fragmented, right? So if the AI we're putting on top of that, this comes back to like a garbage in, garbage out problem, right? So that's thing one. Thing two is that we've got to train commanders and subordinates how to use it, right? You can't just give them this huge tool and not have thought about the policies that govern it and the doctrine that will be incorporated into the TTPs, your tactics, techniques, and procedures, right? We cannot just drop this incredibly powerful tool that is the most consequential since nuclear weapons without any training and say, go use it, and also rely on it.
So 2 good points there, and I'm coming to you, Caroline, to kind of pull them together. So completely agree, General, that as you unpack any statement, there are devils in the details. And I, like with your tanker example, like that's an example of kind of a blue AI that I would expect to work, because it's our data. To your point, Jonathan, it's all going to be dependent on that gold standard source of truth data that we can come back to verify, right? And really important. But you would expect that to work. You would expect things like a red AI that needs a vote from the adversary to be ready for you, deny you that. And so look at the department as a whole, it just doesn't have the infrastructure for that. Now, Caroline, I'm curious in your view, if this red AI use case, which is probably the opposite of a lot of your customers who would expect their use of your system to be presented with a scenario that is close to, you know, a training set, and therefore the outcome should be more likely to be correct.
how does this adversarial red AI fit into OpenAI's business calculus? Is there like a corporate, is there a financial reason to invest in it, or is it a unique DoD challenge?
I think it's both. I sincerely hope DoD is doing a lot of investing and thinking about what the red AI capabilities look like. Mostly, I would point to the leading edge of the Chinese LLMs for those, but that's not exclusively where they should look, and they need to keep their eyes open elsewhere. But I do think it is also a corporate consideration on a few levels. The first is we know that Chinese models, DeepSeek is the one that gets the most attention, and we've done some writing on this. We know they try to steal our model weights, so they try to do corporate espionage, and we also know that the PLA is ingesting as much AI as it possibly can. I don't have a causal link between what DeepSeek is doing and what the PLA is doing, but I'm more making the point in a country where state-owned enterprises are indistinguishable from anything happening in the military domain because of civ-mil fusion. I think one has to watch that carefully. So within OpenAI, we are trying to do net assessment is what we're calling it, which is a very government term, but a comparison of how our models perform relative to what you're calling red AI. We're calling them autocratic AI, and I'm going to explain why in a second. So we are trying to do that. We're trying to get the flywheel spinning. We think there's a lot of work that can be done with the US government on that as well. And we think part of it is because of the commercial reasons for it, but we also think it's because we believe the Chinese models are free riding on some of the American innovation, and we're frankly not okay with that, and I don't think anyone should be okay with that. The reason this matters isn't just because that's not a level playing field, and I have concerns about what the PLA is doing because of all the years I spent inside the Department of Defense. It's because we see the Chinese large language models have reduced elements of a safety stack, meaning that they are more performative on areas like chem and bio that you don't actually want the general population to have more access to. And we know they train censorship into the models, so they won't answer questions about Uyghurs or Tiananmen Square. They will real-time edit away content as they start to answer it in some cases. So for all these reasons, we have a lot of concerns about what's happening in this space. And another example of an area where private-public partnership and deeper understanding can go a long way, I think, in helping the U.S. military. Over.
It's great. From all of this thread, I think it's just infinitely fascinating because we're at the beginning of the competition, right? It's kind of like we've discovered electricity. There isn't the grid. Right? So it's a race for the infrastructure to not just know it, but harness it accountably. And with respect to China, completely game on. The difference in standards and ethics is going to be a big deal. Caroline, let me come back to you, and then I'm going to come down the panel since we're on that topic. What are if you're completely in control of U.S. policy? I want to know, what are the policies you would try to promote globally? And then what are the ones that you think could feasibly be implemented with China today?
More tactically, and then I'm going to zoom out. I would love for there to be policies around what's called distillation, which is there are legitimate reasons that and ways and pathways for researchers, for example, to come to OpenAI or one of the frontier labs and say, we'd like to do some research. This is really good stuff. Here's how we're going to do it. And then there are ways that Chinese large language models come and try to steal that same information to then train and create their own models without having to go through all of the energy intensive and just the resource intensive process of training and shipping out a model. So I would like to see guardrails around distillation for fair competition. More broadly, I would love to see some, I hesitate to say governance, but we used the term guardrails earlier, so I will maybe come back to that sort of concept. Channels for de-escalation, communication, pipelines, such that in a crisis, there are people who pick up on either end. We're like having now a kind of throwback conversation about having phones be picked up while we're talking about the future of the entire world with AI enablement. But I do think there is something to that kind of format, and we will need it for this future where, as you pointed out, Will, you have electricity, but you don't have the whole grid and you don't know how to protect it and harden it, and where it's most vulnerable. We can conceive of it, but we don't fully know. And my last point is that I do think in my experience, the Joint Force and the US military are the absolute best at finding ways to be innovative once you do give them the tools, and they have every desire to be responsible and good custodians of the information and technology they're given. So I'm hugely optimistic that a lot of the advances in how we do this responsibly vis-a-vis national security will actually come from the US military. Hugely, hugely optimistic.
So pulling that thread, so General, when we're doing allies, coalitions, it's all about familiarizing ourselves, right, with how we fight together, and then understanding the things that for national reasons we do separately. Like your reflection, where do you see potential for easy norms and standards with allies and partners? And then if you're willing to project mill to mill with China, what do you think we could get on the same footing on today, feasibly? And then Jonathan, I'd love for you after that to kind of, and like, there will not be one solution. There's a big infrastructure cost that has to be paid. You've got to build the defense planning guidance. Like, what does that look like when we're building a DPG for AI? But first, mill to mill.
So mill to mill with foreign countries assumes that we're actually doing a good job mill to mill with our service partners. And, we still have to get on the same page with the United States Army, the United States Navy, the Space Force, and the Coast Guard from an Air Force perspective. So, and then you have to obviously bring in our NATO partners. And we put a J in front of everything in the Air Force because it sounds good, joint, fill in the blank, and it's easy to get funding for it through Congress. But we have to actually, joint can't be a buzzword with AI. So we're going to have to actually lean into this. And it's, doers do what checkers check, right? So we have to start actually putting our money and our talent where our mouth is. And this cannot be bolted on. It is going to have to be baked in from day one. And I will tell you, we're already behind. To your point on the how do we Durloff or liaison with China, I think step one, and I am not a Navy guy, may be global commons and sea stuff, but I will default to my Marine brethren on that one. Over.
I think the DPG for AI question is super interesting. I'll highlight a couple of areas that we haven't really touched on yet. I mentioned one earlier, which was the data foundation, making sure the data is standardized and clean and we can all trust it. And that needs to happen sort of department wide, which is a monumental effort on its own because of the federated nature of the different services, et cetera. The second thing is AI's impact on supply chain and manufacturing. So the reconciliation bill, I think, had $1 billion, which was one of their biggest line items for AI, which is leveraging AI for munitions production. In a war in the Indo-Pacific, like the general said, attrition is going to be real. we're going to need munitions on a scale that we can't really comprehend here. And so the industrial base as it exists today cannot support those requirements. It just can't, full stop. And so figuring out a way to increase the capacity of our industrial base to make not just the munitions, but everything else we're going to need is super important. The under sort of the corollary to that is also figuring out our supply chains. I think this is a narrow but very interesting use case for AI, which is most contractors, I think it's above 80%, really lose visibility of their supply chain below tier 2. They know their direct suppliers and that's about it, but they don't know who their suppliers use, so on and so forth. And the first Trump administration published an excellent report in 2019, I think, on the industrial base. It said that this was a huge issue. And so if we can start to leverage AI to really map out and fully understand our supply chain to then start building in redundancies and resiliency, that would be a huge win.
So I'll go ahead. I'm going to tee up 3 questions that are going to go to each panelist. So you've got a little bit of time to think about them. Caroline, what I'd like, because you are in the center of it there, I'd like your prediction for what's going to be the biggest AI accomplishment this year in the future. What's the prediction from you now in the seat at OpenAI? General, what I'd like your reflection on, given your battlefield experiences, what do you think that we're going to get wrong from a training perspective, and what would you do to try to get ahead of that and correct it? And then Jonathan, from a budgeting perspective, because you budget for investors and you budgeted for the DPG, what are we going to get? What are we going to throw our money after that's going to be wrong? So I want a sense of the possible, and then after that, a sense of where are we going the wrong direction. But Caroline, over to you.
I think my prediction, and this is obviously not as much the space I'm in at OpenAI, but it's just my sense of where the greatest scale of change might happen in the rest of this calendar year. And I hope and sincerely wish that it also comes to the Department of Defense and everyone in that enterprise, is around agentic workflows and full end-to-end transformation of those workflows. So for example, we get asked a lot of questions about how does OpenAI use AI, and it's a huge top-down, middle, bottom-up, every layer is pushing on it. But an example I'll give you is not maybe memorable, maybe not, but I think that's sort of my point, that it's not always the shiny parts of the enterprise that most need transformation. So as we've grown to now 900 million weekly average users, you can imagine that the demands for customer support for the customer support team are totally ballooning. They have created a system where agents have scaled how they respond. So while in the last year there was something like a 200% year-over-year increase in the number of tickets received by the customer support, they only scaled their headcount by 30%, and they used the headcount using agents to do more efficient workflows. And when you actually look at the type of, it's almost like the munition counting charts. So when you look at what that looks like for each ticket as it relates to being triaged, it's a pretty remarkable scale of what you can do with not as much headcount. And I think the way I could see this translating to the Department of Defense is, as I said, in areas like cyber defense, where you're not going to grow a lot more cyber expertise and operators. You're not going to get a lot more end strength. The services aren't going to suddenly grow that overnight and ship it over to Cybercom or have it at all the echelons it needs to be. But if you do it right, AI can be a real enabler and force multiplier for units for individuals and for commands. I'll stop there.
So the training question, what is the training going to get right? It's absolutely going to reduce cognitive overload for the human, enabling everyone to have a higher level of situational awareness. What the training potentially gets wrong, or could get wrong if we don't pay attention to it, is over-reliance on the AI or the AI agent. And I'll give you a prime example, GPS. I would argue that 9 in 10 navigators in the United States Air Force, if I took their GPS solution away from them and said, okay, here's your sextant and your diviner, and I need you to celestial navigate back to the house. While they theoretically were trained to do it, they're not proficient at it anymore. And so you cannot lose that muscle memory of being able to do rote tasks, because while the war with China, if it's not over in 72 hours, we have big problems anyway. But if it is longer than 72 hours, all of the stuff that we take for granted, like the blue GPS dot, like the JTIDS network, that's all going to be gone. And what's going to be real sexy again, it's HF radios and Mars stations and potentially typewriters. So what the training could get wrong is throwing the baby out with the bathwater and abandoning being able to operate without the AI agent there on your guardian angel on your shoulder. Over.
You know, in the Marine Corps, we can only afford compasses. So I think I don't know where to go, at least. I think my answer on what we're going to get wrong is sort of big picture. It's because the tech is, the capabilities is evolving so quickly and so poorly understood. I think we're going to get the policy and the frameworks wrong. If only because, you know, a best case scenario is that, like, we've got good policies and frameworks in place, but the processes we use to update those are going to fall so far behind on the tech development that they're going to be out of date the moment they're published. You know, the DoD directives, the policies that sort of govern everything the department does. We actually have one for lethal autonomous weapons. My team was the one who sort of updated it in 2023, but it's probably out of date or will be soon, right? And so how can we figure out ways to make sure that these guardrails and the policies and the governance is updating on the same speed of the tech development itself?
You know, so hopefully you've been able to see, I've been really, I mean, what great perspectives from everyone across the panel. And I think the one thing that we can take away is that we need to be having discussions like this very frequently. That a lot of what we think today will change a year from now because the tech is moving so quickly. Without public-private partnership, we're going to be in a world of hurt on determining how we adopt safely. And I think finally that there is kind of an inherent rub here between humans in the loop for accountability, but that's a slow loop versus the power of having agents and autonomous OODA loops with greater risk. So no easy answers here, but good questions to keep probing here at the Nunn School. And the reason to keep probing, I'll end with good friend and colleague, General Tim Ray, who was in charge of global strike for the Air Force. So a lot of the assets that you see now on display. And we owe operators and those that are in harm's way the ability to understand risk and accept it. I had to do quite a lot of that with General Ray. We're going to fly an aircraft that's a little more dangerous than normally. We have to understand the risk so humans can accept it. What we need out of all of this is the ability for operators to understand the risk so they can make a human decision about accepting it. If we do that, they're trained to do that. So things to get done as a society. I want to thank our panelists for their great responses, for letting the questions go a little more probing, and just for being here today. Let's thank them with a round of applause.
Thanks, Adam. Thanks everyone for being here. I hope you've enjoyed the earlier panels today and at least started an important conversation both here in Georgia and of course around the country and around the world. I'm really thrilled to be able to moderate this final panel, which seeks to examine the issues we've been talking about today in the national security space from the commercial perspective and how the commercial sector is seeing the demand signals that were discussed earlier today, whether that perception is the same as those currently in government, and what issues remain. We have four outstanding panelists joining today. First, General Timothy Ray. He's president and CEO of Business Executives for National Security, which is a nonpartisan nonprofit comprised of business and industry executives who apply their experience to address pressing national security challenges. He's a highly decorated retired U.S. Air Force four-star general who most recently served as commander of Air Force Global Strike Command and as the commander of Air Force's Strategic Air, United States Strategic Command. He was a member of the Air Force's team of senior leaders shaping future force structure, modernization, and budget priorities for the service, and is widely recognized for his expertise developing, fielding, operating, and sustaining security capabilities across multiple disciplines. Next, we have Aditi Kumar, who is the head of defense policy and partnerships at Anthropic. She's also a non-resident research fellow at Georgetown Center for Security and Emerging Technology, a distinguished visiting fellow at Penn's Perry Worldhouse, and a senior fellow at Harvard's Belfer Center for Science and International Affairs. She previously served as the principal deputy director of the Defense Innovation Unit within the Department of Defense, where she led numerous initiatives focused on the accelerated acquisition and fielding of commercial technologies in response to urgent military needs. She also was a senior advisor to the Undersecretary of Defense for Acquisition and Sustainment, and I had the good fortune of first meeting her when she was executive director of the Belfer Center at Harvard. Dr. Thomas Kerfus is the chief manufacturing officer here at Georgia Tech and executive director of the Georgia Tech Manufacturing Institute. He is also Husco Ramirez Distinguished Chair in Fluid Power and Motion Control and Regents Professor in Georgia Tech's George W. Woodruff School of Mechanical Engineering. He recently served as the president of the American Society of Mechanical Engineers and was president of the Society of Manufacturing Engineers. His research focuses on the design and development of advanced manufacturing systems targeting secure digital manufacturing, additive and subtractive processes, and large-scale production enterprises. And last but not least, Michael McFadden, who is the Chief Technology Officer at Sigma Defense, a defense technology company headquartered in Perry, Georgia, providing CJADC2, C5, ISR, and DevSecOps solutions to national security customers. He is a technology leader specializing in software engineering, data platforms, and the application of emerging technologies, including AI, to complex operational challenges. He was previously CTO of Solute, where he helped build and scale engineering teams delivering advanced capabilities to defense customers. Thank you all for being here. So the first question I want to talk about, we just heard a panel covering the demand signals emanating from the national security sector, principally the Department of Defense. But how is the commercial sector responding? I'd like to begin to answer that question with Aditi. Anthropic, her company, has clearly been supporting the department in a number of critical ways, but is now involved in a disagreement about how their tech can be used. Aditi, could you describe how Anthropic views demand for AI in the defense sector and what the recent controversy means for that work going forward?
Yeah. Hey, thanks, Josh. Thanks for having me, and thanks to all the fellow panelists for this discussion. As you probably know, Anthropic has been quite forward-leaning on our work with the Department of Defense and the IC community more broadly. We were the first frontier AI lab to deploy on classified networks. And for the past about 1.5 to 2 years, we've been working pretty closely with the end users in this community to build and test specific applications of AI. I think we're all learning what these applications can be. And it's been a very productive partnership in understanding that. As for our current dispute with the DoD, we're hoping for a positive resolution so we can keep on doing this work because it's core to Anthropic's mission. And so I'm hopeful we'll find a way forward, although I won't in this panel comment on the ongoing litigation right now. But more broadly, Josh, to your question on demand, at Anthropic, we're seeing significant organic pull from the national security users, people who discovered the commercial product and are now asking how to use, in our case, Claude in their mission context. And I think that bottom-up demand for us has been a stronger signal than the very good strategies that have also come out of the department. In our case, the demand has come first from the operational side, meaning principally the combatant commands and some folks in the intelligence community who have missions related to intel analysis, scenario planning, risk assessment, and things of that nature. It's a little surprising that the more routine applications of LLMs across the workforce for daily productivity and for many of the things I imagine we all use it for in unclassified contexts, that has lagged. And then the final point I'll make on the demand is that, as always, I have to make this point, the transition from, we want AI to here's a funded requirement with a clear technical spec. That's always been the gap and a challenge for DoD. I think a good example of this has been the recent DIU challenge with the Defense Autonomous Warfare Group that's focused on autonomous vehicle orchestration. That was a very clear demand, funded requirement, a clear sort of multi-step plan to test technology. I think we need more of that type of signal from the department.
Great, thanks so much, Aditi. General Ray, I'd like to turn it over to you. You've obviously got years of deep and broad experience from the uniformed leadership side, and now lead an organization that helps the private sector leaders who want to solve national security challenges do so. From your perspective, is the DoD seeing the challenge, I don't say correctly or in the right way? Is the emphasis in the right place? And does the commercial sector see the problems in the same way?
Okay, how about now? Yeah, I think there's a lot to be unconcerned about here. So what I would say now, being in the business side of the world and understanding the business side of the world and understanding the military problems. So just kind of as an aside, I've been a JFAC, so I've been someone who runs an integrated air campaign. So the decision-making and that kind of stuff I'm very comfortable with. I'm also a human factors engineer, which means I think about the connection of the people. And I've done a lot of delegation over time. So what that means is when you delegate a decision, you always have to think through accountability, authority, and responsibility. That's nothing different here, and you're just going to have to be a lot more methodical. And so I would say I observe the imperative of data to drive, what my colleague just talked about as the beginning places. The war on terror was a very data-rich environment. It just makes complete sense. But if you go from there, past that, you're going to find yourself in a very disjointed world, and it's to be understood. The military is probably one of the most complex organizations on the planet. There are segments of it that have commercial parallels, but there are so many segments that are unique to it, as an entity, that is really tough. You want to scale something, you're not going to scale it across the military. You're going to scale it in small areas. And so there's this management of expectations about what you're going to bring to the table. First things first, as you just said about, but when you start talking about change, there's normative change and formative change. Formative is we do everything different, clean sheet. Normative change is just optimization. And you'll hear a lot of people say, this changes everything with my product. And in truth be told, it really only optimizes a few things. So it's mostly normative change. And many managers, either civilian or military, are not great at change management. And so you have this need to modernize and do a lot of things, but you don't have a lot of great change management. You don't have a lot of bandwidth. Moreover, the infrastructure in terms of capacity doesn't make it ripe to do that, right? So we talked about decision-making in the battlefield and logistics. The supply chain's broken enough that I'm just going to say, do I run out of weapons at 2:45 today or at 8 p.m. tonight? It kind of doesn't matter. You're going to run out too soon. So until you make this move to not just to rely on the defense industrial base, but to a dual use technology capacity in the United States that gives you that scalable, affordable mass, you're going to have a decrease in your capacity to do more. So you've got to embrace that reality, and that's starting to happen. Until that becomes a bigger role inside of the national security environment, you're just not going to see people coming to the same place on the business and the military side, because it's just a fundamentally different world. So you'll see spotty applications, some good stuff on the data management for analysis. Change management of processes is going to be limited, but until you change the foundation of what you call the national security industrial base, you're just not going to create enough opportunities for it to be as real.
Thank you. Dr. Kerfis, I'd love to hear first for our audience, to talk a little bit about Georgia Tech Manufacturing Institute, what its role is, the kind of work it does for government customers or government stakeholders, and then talk about from the academic perspective and from applied research-based entities at schools like Georgia Tech, what role do they play in this ecosystem, and how are they seeing the demand signals emanating from the Department of Defense?
Sure. So, our role at the Manufacturing Institute is to take fundamental work that we would do at the university or at any place. We work with national labs, we work with a variety of universities, Department of Defense labs, but take some of the fundamental work and scale it up, so to a higher technology readiness level. So you've got benchtop TRL 1, 2, 3 in the labs over here, and then you go to our pilot facility. By the way, you're all welcome to come out. It's on 14th Street. We've just opened up 65,000 square feet of facilities and so forth to really scale capabilities up. And we're sort of in the middle. So TRL 4, 5, 6, maybe 7 or 8. And then we might go to some of the larger scale equipment that would be kind of the size of this room at some of our national labs or, for example, over at NIST, but really moving that technology forward. And so the demand signal, I mean, what we're really seeing is acceleration, because you see what AI is doing, and all of a sudden, hey, there's a new model out there and there's a new capability out there. We're digitally connected. And I think the key thing here is the digital connectivity, so that it really allows us to move forward. And as you heard in sort of the previous discussion, it is this sort of overall demand. We need data. It turns out, a big issue is going to be, how are we going to get the data? But if you're familiar with manufacturing, we've got control charts. In fact, I just finished writing a sort of elements for a National Academy report on the Manufacturing Institutes. Shewart, he's the guy that came up with control charts. That was over 100 years ago. So, we are collecting data. The real question is, okay, how are we going to use the data? We heard about cybersecurity, so now we're very concerned about security. If I'm an OEM, I'm a prime. I won't, let's say, automotive, prime or an aerospace prime. I can now look down my data and my supply chains, and I can understand what the profit margins are of my company. So I know exactly who to squeeze. So you have to be very careful about how you share things and how you move them forward on a commercial side. But I can tell you where it's really hard in terms of dealing with defense is a lot of the security and so forth. It's really, hey, they're just a bunch of walls. We're not connecting our machines. We're not moving it forward. Imagine trying to live your life without a smartphone. Even my mother, 88 years old, is using her smartphone, and she ties into all sorts of capabilities. She checks the weather today, and she says, she's tying into 17 NOAA satellites, beaming down 4 terabytes of data an hour on the 7 supercomputing models to tell her whether she should bring an umbrella or not when she heads out to go shopping at 1 o'clock this afternoon. And, you don't think about the power that you have there, but what we're seeing on the defense side is that they're really not letting us move forward. And by the way, it's not just DOD, it's, over at NNSA, over in DOE and so forth. So how do you bring all this together and really leverage that power in a safe and secure manner? A lot of it's there. It's the implementation that's really, really grinding us to a halt.
Thank you. And a great segue into my next question for Michael. Who is in a leadership role at a company doing business with the Department of Defense, seeking to do business with the Department of Defense. Michael, what are the big challenges that face a company like yours, particularly when it comes to developing AI or AI-enabled technologies with national security applications?
I think, the way I think about it is, our partners at companies like Anthropic, do a lot with their technology, but one of the things that they're doing is really democratizing software development, right? And kind of linking it back to the demand, which will lead to the challenge. You can't if you're in this space, you can't look at a blog post or a video without seeing people just building apps, normal people, some with limited technical, ability to build apps at breakneck speed. You give that power to normal engineers that have been doing this for 10, 15, 20 years, and they can go even faster, right? And so the demand now is you have sort of grassroots efforts, people that have friction in the DOE or DOW ecosystem, saying, hey, I have this problem. It might be a small problem. I could almost solve this myself at this point, right? But then I look down the barrel of, how do we get a procurement out? How do we get a funded requirement out? How do we then issue a contract? Okay, now we give that to a prime contractor. They have software. How do we get it accredited? How do we get it out to the field? And, we've been dealing with those issues for, the last 30 years in the industry, how to get software out faster. But there was at least an impression that, yes, it was slow, but it was hard to build the software, right? So if it takes 12 months to build something and 6 months to field it, that's not great, but it doesn't feel that asymmetric. If it takes 2 weeks to build the app and now it takes 12 months to field it, that feels really bad, right? And I think one of the big challenges that we look at when we think about not only using AI to build systems, but AI-enabled systems, is as an industry, we're really used to deterministic systems. And we look at AI and a probabilistic nature of that and think, hey, this is non-deterministic. How do I trust it? And I think the thing that we forget is we have humans doing jobs today, right? And humans are non-deterministic by their nature, but we invest in training and guardrails and process that we put in place that takes those non-deterministic humans and tries to get them to do the right thing with a high probability of success. Not necessarily 100%, but a high probability that we're comfortable with. And I think there's just a whole cognitive shift that we need to have as an industry to say, how do we put those same kind of guardrails in place and feedback loops and training evolution such that we can feel comfortable that those non-deterministic systems will perform? So those are the two big challenges I see.
Okay. Thank you. Aditi, I'd love to hear your response to the same question and particularly lean on your experience at DIU. For the audience, DIU is an important entry point for commercial solutions to pressing national security challenges at DoD. Aditi, what do you think the big challenges are for either your particular company or for any company seeking to field AI systems or solutions to the government?
Yeah, I'd like to underscore some of Michael's points. I think where we are in the technology development right now, one of the biggest challenges that we face, I think all frontier AI labs face, and our government partners as well, is how do you test and evaluate these technologies that are developing so quickly to make sure that they are useful and that they're safe and that they're adding value. One thing I worry about a lot, which Michael, you're alluding to, is automation bias. So as people start using AI, how do we build in systems so that we are still checking the things that matter most, that we're not over reliant on these in contexts where the consequences of not having full human cognitive focus on the problem could lead to pretty catastrophic failures. So that's one flavor of it. Another really benign example, which is as much a technical challenge as anything else, is as we're deploying these systems on classified networks, we're dealing with sensitive information. A lot of times, the sensitivity of the information changes with aggregation, right? So when you're looking at data at the levels that an AI system is processing it, something that maybe that would have been secret on its own becomes top secret or even higher because you're aggregating so much information. How does an AI system deal with that? How do we build in the right checks to do that? I think those are really hard problems, and the list is long. And so I think figuring out ways that the private sector can partner with academic institutions, and I will take any help from Georgia Tech here, as well as governments to think about what these frameworks need to look like, how we're going to test, evaluate, and update those, because models are updating every couple of months. And the capability is changing by leaps and bounds. And so we'll have to keep up with that, which is a pretty sort of all hands on deck challenge.
Thanks.
Yeah, I'd like to agree with everything that was just said, but give you a very important dimension. I'm a bomber pilot, and I had to carry my portfolio to Congress. So I had the ICBM, the new bomber, the new cruise missile, nuclear command and control, a lot of very complicated technical stuff. I walked in to explain that I was going to use models-based systems engineering. And the look I got from the staffer is, please, General, tell me you didn't just buy the magic beans, because they know clearly I'm not an engineer to have that kind of expertise, nor are they, as those who have oversight over the process, a technical expert either. And those two players are the ones most accountable now to bring that capability forward. And no one's going to get money until those who are accountable and have oversight are comfortable with it. And you heard clearly the dynamic piece of this. So it goes beyond just having those templates, is finding quickly a way to give those who have oversight a better set of tools, who have no resident expertise themselves, to do something in so complicated of an enterprise that doesn't exist anywhere else on the planet at a pace that no one understands. So this is really hard, is my point. And it have to bring in the congressional oversight. When you have them as teammates, you get everything you want. Let me just be very clear that if you can pull that off and they trust you, then we can't be beaten. But there's such a debt in capacity and rebuilding our institution, and it's so complex that you've got to translate the technical opportunities through the operators, those who have to bring it to the hill without some kind of equity in a contract, and let them believe you and then keep the money in play for a long enough period of time to make it happen. So I agree. That's where success really lies.
Yeah, I really appreciate you bringing up the congressional aspect. As a former congressional staffer, I can tell you how strained, particularly in personal offices, but even on the committee staffs where a lot of this expertise lives, how broad their portfolios are, how difficult it is to keep up. So to poke at that a bit, I'm curious, what type of tools can either private sector leaders or those in uniform or the civilians that support them do to help make sure that that our democratic institutions, small d democratic institutions, can keep up with the challenge?
One of the things I'm doing at Ben's is one of our campaigns is that the capital markets to be part of, the national security enterprise. The way a private equity firm would run a due diligence process gives you a breathtaking set of insights. And the oversight they're going to exercise on an investment just absolutely crushes anything that Congress would do. So I think that there's a way to talk to those who do this and create a better set of tools for the staffers. That there has to be a way to create that relationship, preferably with somebody with no equity in the outcome, right? So that's where, as a nonprofit, I'm trying to make sure that the experts I bring in aren't making any money, and their validation of an idea is now priceless, because no one's going to make any money. So if you're in the Hill, everybody that came to you had an agenda, and somebody wanted to make a profit or a contract or state their case. How do you get enough of a dialogue where it's an honest broker dialogue and you build the skills of those who are going to evaluate and oversight? I think there's a lot of opportunities there, and you have to get it done, or we're just not going to move fast enough.
Great, thank you. Michael, for you and anyone else who'd care to respond, dual use is thrown around a lot as a term of art, as a buzzword or buzzwords. What does that mean in an era when these general purpose AI tools are proliferating, are developing quickly, where the governance structure either doesn't exist or is catching up? Michael, from your perspective, running a business that is working on some of these challenges, what does dual use mean to you? What does it look like to you? And why does it matter?
I think there's two different dimensions to that. First, as a commercial company, you think about, can I address a broader market that includes, the department, right? And I think the good news is that it is easier today than it was a year ago and 2 years ago to build a lot of these systems using some of these generative AI tools. And so, the size of the market that you're willing to address with a product is maybe smaller now than it used to be, because the effort required to build some of these systems is quite a bit smaller, right? And so I think this does lead to a lot of new opportunities for dual use technologies where, maybe the department is a large consumer, but there is also, a niche market in the commercial sector that you can now address that maybe on its own wouldn't have been addressable if the investment required would have been, much larger to bring that product to market. So I think that's the good news. I think the bad news is, and Aditi mentioned this, is these technologies are changing at a pace which is hard for the department to keep up with. If we look at some of the models that have come out, even since, say, last November, right? If you go back to even September of 2025 versus the iteration on the models and the capabilities and the tools that exist in March of 2026, it is night and day. And I think that poses a real challenge if you are a company trying to bring dual use technologies to the market. These things are evolving well inside the acquisition cycle that the department can sort of deal with, right? And so to put those feedback loops in, those test and evaluation cycles, how do we feel about cybersecurity in an era where humans didn't even look at the code in software necessarily that was being developed, right? And so I think there's a good news story on the dual use side, but also some new challenges that come along with that.
Dr. Griffiths?
I just like to add, I mean, I agree completely there. One of the things that we look at is, yes, how do you design your infrastructure in your manufacturing operations? So people say, oh, well, connectivity, et cetera, et cetera. But one of the things we do when we work with a company to design their backbones, and we've done it for major OEMs and primes, aerospace, automotive, and so forth, is even what does the data architecture look like so that you can move it forward and you have the flexibility. Just as an example, a modern automotive factory no longer has conveyor belts. It has autonomous modal robots. So there are 4 little robots that go underneath the corner of the car and they're moving along. You think that they're conveyor belts and moving along, but if there's a problem with this car, it gets flagged. Little AMRs, autonomous modal robots, pull them out. The line closes up. You work on it. And then when you're done, you say, I'm done. And it goes down to wherever it needs to be inserted back in the line, and in it goes. And we're doing this with hardware and the same thing in terms of software because things are changing so rapidly, and it's just competition. So this is, again, on the civilian side, the commercial side, the competition is just driving us to move things forward. Even our product, an electric vehicle is more like a computer with plug and play than an internal combustion engine vehicle. And you drop those 4 motors in on your vehicle. They come with their torque speed characteristics, so you know exactly how they're going to perform. It goes to the electronic control unit on the car, and then it automatically tunes itself for optimal performance. So tremendous flexibility, by the way, also tremendous opportunities for cyber intrusion, but tremendous flexibility, tremendous capability, but it's a very different thinking. Your automotive engineer today looking at these types of systems, vastly different than the automotive engineer from 20, 30 years ago.
I'd like to throw one more caveat on that. I think all that is incredibly important. It's really, I think, paramount for us to understand what I call the national security industrial base. We tend to talk about the defense industrial base, right? So we as the American military are never going to get excused from doing the exquisite, right? Our partners and allies want that. So the defense primes have consolidated, but they do that one piece. There's this very significant piece of dual use technology, affordable, scalable mass, right? So we did launch drones. We copied the Iranian drone. We did do that. So we are doing counter US. And then there's the infrastructure piece. For the dual use tech, we are the most innovative country on the planet. We prototype it and then we outsource its production. And because of that, we do not have the manufacturing base to do the things that we need to do. But when we become more conversant at doing that, if we get the investment and the return of that, you create a fundamentally different platform for AI to help, because it's not always living in the exquisite or the scary or what I'm afraid of. It becomes really what's in the supply chain today, right? There's a few companies who produce something not because they dream of the right part, they go to what's commercially available. Now you have a very different dual use dynamic. And I think it's really in our best interest not only to do that, but you can leap forward over the Chinese and produce. Don't have to just compete with them, but you could become a new version of it. There's a formative piece here if we're really, really intelligent about that. And I think until that piece comes to life, we're still going to struggle.
I want to go back to you, General Ray. For the organization that you currently lead, what are you hearing from business leaders interested in national security about AI and AI-enabled technologies. How are they thinking about it? What do they see as the challenges? Are they the same as the way department leaders are thinking about them?
I think that some pieces are really easy, right? So we talk about data, Project Maven, that's a sweet spot. I think the cybersecurity piece is another sweet spot. I think we benefit from a lot of dual use capability out there, and that's a good safe place. I do believe that there's still a disconnect in terms of what AI can be used for. And I think we just kind of go straight to the kill chain being the thing that we want to worry about, but there's so many other processes. And I think once you have the conversation with them, oh yeah, we could do that. We can create more efficiency and effectiveness. They have a difference in perspective for the time horizon to make a decision, the exit, the money, and the risk. But I think it becomes a little bit more of a reconciliation that, hey, I don't need to go to the whole military. I need to go find that section of the military, create that relationship, because you have to iterate on the data and the tools and then hopefully expand from there. But I think they are, much like you heard here, concerned at the total addressable market. There has to be this adjustment for what that really is, and it's smaller than I think than what they want to hear.
Thank you. Aditi, I want to once again lean on the two sides of this problem that you've faced in your recent career, from both the government side and now the private sector side. Where are policy and government's decisions either shaping or constraining the decisions that private sector actors, or at least the company you work for, how are they shaping the decisions you're making about where to place resources or place effort? And what have you been surprised, or what have you learned that you had not had a chance to understand when you were on the government side, now that you've seen it from this perspective?
Yeah, I think, tying in maybe Josh, your dual use question, taking a company that has created a commercial product first that happens to be really good at national security applications, it's finding how we plug into those missions and those contexts in a way that is responsible and safe, and supports the national security mission. So we have built an incredibly powerful model. It is, for example, really good at cybersecurity, both defending it and also going on the offense. We obviously don't want those offensive capabilities to be widely available to the world, but it is perhaps really important for certain members of the defense and intelligence community to have them. And so how do we enable that from a technical perspective? And then how do we manage the responsible use of that from a policy perspective is something that I spend my time thinking about. It is something that has to be done in partnership with the government, and Congress is a huge part of that. We already talked about testing and eval. I think that's a major piece. I think as adoption increases, thinking through the standard operating procedures for using this technology, what are the gate checks going to be? At what point do we want humans checking the work? At what point do we want a lawyer signing off on outputs? I think those are all process questions, workflow questions that need to be addressed as adoption increases. I think training and education is a huge part of this as well. How do we equip operators to use this technology in ways that are responsible, so that they understand what the fragilities of the model are, so that they can safeguard against them? And then I think that for us, there are some technical questions around what those safeguards look like. We obviously want the model to limit certain capabilities that are harmful. For example, child safety. The model should not be responding to queries that endanger child safety, but we need to do that in a way where the child safety, of course, is universal. But we need to think about areas where it's a grayer space. Cybersecurity is one example. Biosecurity is another example, where there are legitimate government use cases for those things, and there are illegitimate use cases, and we need to figure out how to enable the legitimate ones only.
Often when we're talking about defense-related technologies, capabilities, there's this dichotomy drawn between speed and responsibility. I'd like to really hone in on that responsibility piece. And starting with you, General Ray, I'd love to hear your thoughts on where responsibility exists or how is it shared? In what ratios is it shared between private sector leaders, government leaders, military leaders, in terms of how we're going to use these technologies, how quickly we need to be developing them, what limitations ought to be on them?
Yeah, I'll go back to the comment I made about accountability, authority, and responsibility. There's a handful of people in this conversation that are centrally accountable. And so they're the ones who have to make the decisions on the context. And, they're the ones who are going to have to do this maybe with very little time to think about it. So I think it's really important for them to have an outsized voice that gives them the comfort level of when conditions change, right? So as a JFAC or as a deputy commander for a combatant command, you created triggers for conditions to change and different cascading changing authorities. You have to follow a similar model. That's not necessarily a process the private sector is as familiar with, but I'm completely convinced it'll happen. But I think that there needs to be a little bit of grace on both sides to say, we don't know exactly what it looks like. We have a framework to start from. Who's accountable? How do they delegate authorities? And whose responsibility? And how do we keep that clean? When everything you're doing is dependent upon the quality of the data you're doing things with, there's an inherent amount of uncertainty. There's an inherent amount of uncertainty about context. So context matters, completely here. And so I think you're going to have to make sure that as you go down the path, those who are accountable can bake in their skepticism or confidence in what they're working with and how much risk they're willing to take. Once they're familiar with it, then you can train a group of leaders that follow you. I mean, if you're a senior leader in the military, you're always training your people how to delegate. This is not a natural once and done thing. It's a process to go through experience. So we're going to have to roll around in this for quite a bit. I think you have to give primacy, though, to those who are accountable. I do believe, I think Carol said it earlier, they really do want to innovate, but they have to do it in a way that they don't lose control. And I think the American people would be comfortable knowing these, the people in the uniform are not just going to do this willy-nilly. They're going to walk through this at a very methodical pace. It won't go nearly as fast as the private sector can go or is willing to go. And I think that's going to be the natural tension.
I have a few more questions, but for this session, I'm going to open it up in just a few minutes to audience questions. So please be thinking about those. Dr. Curvis, I'd love to send the same type of question to you about this question of responsibility, how you see it play out in the academic or applied research context around AI tools or AI-enabled manufacturing. How do you see accountability and responsibility present in your space?
Yeah, so I mean, I think, so to the generalist point, there is uncertainty. Now we have data, we can actually start to quantify that uncertainty. So we've got to start thinking about, okay, when I present you with a quantified uncertainty, what are you going to do with that? I mean, right now in manufacturing, people just want to know, is my part good or is it not good? Does it pass the test or not? Well, what if you say, well, it passes the test with a 95% probability. Is that great or not? Well, it depends. Are we talking, a valve in a gumball machine? Or are we talking a valve, in your heart, right? And so these are the types of things that we have to be thinking about in terms of really even retraining our workforce and making use of it. In terms of accountability, I think that there have to be a lot of checks that are going on. And in industry, there are a fair amount of checks that are happening that people are looking at. But the idea, again, is there's going to be very fast moving capability. So as we design our systems, whether it's on the data side, the electronic side, the architecture side, again, you go to that modern automotive plant, if you strip out all the equipment, basically you've got this enormous, multi-acre operation with QR codes every 3 or 4 meters on the whole building. And that's how the robots know where they are. And so you design your systems so that they can move quickly, and your workforce has to be able to design, is designed to move quickly. So it's a completely different, and it's a completely different thinking. I guess, we've got Eric Hoffer, 20th century philosopher. One of my favorite statements, he said, in times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists. I mean, I think that that's what we're facing right now. That was true in the 20th century. Things are moving even faster now. And, so it's even more true today, if that's the appropriate terminology.
Thank you. Michael, I'm interested from your experience as a business leader and as particularly one who is specialized on the software side of things, how AI has changed your company's decision making, the way you think about the problem sets that your defense customers have, and what excites you about the next few years in terms of what the private sector is going to be able to bring to bear in support of national security?
I think the thing that really excites me is, kind of going back to the comments I made in dual use. There are, there's finite time and resources that industry and DoW have to put towards the problems that they have. So everything is, racked and stacked. As you know, as a staffer, you get 4,000 ideas coming in the door. If you're an appropriator, you got to figure out, what to go after. And there are whole classes of problems that are solvable now within time and budget constraints that just weren't, many years ago. And so I think what I'm excited about is I think we can solve, real problems, real friction, operational efficiencies, quality of life improvements, both at the tactical edge and, back at the ranch, so to speak. And I think, this concept of innovation, balancing speed and responsibility, I think that's actually a really interesting area to get at, because I think what it allows us to do is to sort of think about how we build trust into our systems, right? I don't think that's a thing that we've really thought about very much as a commercial industry. We think about how to solve the technical problem, generally speaking, but we don't really think about how to build trust into these systems. And I think that's a whole interesting area that we can partner with academic institutions, other commercial partners, policymakers, all at once to come together and try to answer that question of trust. And really the idea of being able to then sort of mature technology, policy, and doctrine sort of together is, I think, a really interesting opportunity that we have in front of us.
Thank you. General Ray, I'd like to ask you to put the uniform hat back on and think about, or rather talk about, as a military leader, do you see the next few years, next few decades of how this technology is incorporated into our defense capabilities having the most impact at a tactical level, operational level? Are there strategic implications here, or are the strategic implications just the sum total of those tactical changes? Like where does the battlefield, where will it actually change from your perspective?
I think as you watch the Pentagon do what they're doing now, Secretary Feinberg and his approach, some of the service secretaries, their approach to play the game differently, to have a stake in the industrial base. You clearly see players coming to the table with lower cost opportunities. They're figuring out that they can't lean on the DO or DOW, DOD, whatever your flavor is, to be the scaler for them, right? So they know that they're going to have to inherit a lot of that risk and make stuff happen. I think when you watch that whole system get healthier, where is your supply chain? Where is your low cost, attritable capabilities? When does manufacturing in the United States get healthy? When do we get serious about energy abundance in the United States? That tide changes everything for the national security players. So if you try to lead from the Pentagon, you're gonna have a hard time. But there's a sense that you can change the whole national security industrial base and change the equation. So I think if that happens, then all levels prevail because you can make greater decisions, you have greater margin as a country. I would like to see that to be the case. And that strategic margin plays at the strategic, at the operational, at the tactical level. What you can't do is pressurize it the other way around, right? So until you buy more strategic margin, then you're going to find yourself kind of challenged.
Thank you. The final prepared question I have is for Dr. Kerfis and also Michael. We're at Georgia Tech. This is, although we've talked about some really big global issues related to AI, I'm interested in your thoughts on the role that Georgia, Atlanta, the robust defense and national security ecosystem we have in this state, whether it's military installations, obviously private sector players like Michael's company, and of course government leaders as well. How do you see the institutions, people, and role of Georgia and the broader Southeast in this conversation?
Yeah, no, I mean, it's a good question. And actually it gets to the whole point of the supply chain, the ecosystem, and so forth. A lot of times we think about, okay, how are we using AI? And we think about the primes and the OEMs, maybe the tier 1 suppliers. But remember, you get down to the tier 5, 6, 7, the mom and pop shops that are providing the nuts and bolts for the F-35. Those all have to be validated as well. And so how do we bring everybody along? To a certain extent, it's not that far away. I go out to a lot of plants, here in the Atlanta or the Georgia area or Southeast, and you say, okay, well, how many of you have your free Google Drive? And everybody raises their hand. How many of you have broadband connection to your plant? You could be out, way out there in some rural area. I still have, a hotspot, from, let's say, T-Mobile or AT&T or whatever. So they all have it. So they all have the basic infrastructure necessary to move this forward and sort of connect it up. The real question is how do you bring it together? So it is not difficult to do, but we have to do it in a coordinated fashion. And again, security is really important because you don't want to let all of the information out, and that is sort of critical even in terms of survival. Because again, as I mentioned, if I'm the prime and I know exactly which my suppliers have a higher profit margin, I know which ones I can squeeze a little bit more to sort of get the funding out of them. But it also is an opportunity really to integrate our supply chain. So look, we heard the word resilience. That's a big hot word. So now I can take a look across my entire ecosystem and find out, okay, well, what if a hurricane hits, or what if a major power outage happens in a certain area? Can I redirect my supply chain to keep things flowing and to be resilient? One of the things we learned from COVID is we want shorter supply chains, right? And so we don't want a lot of ships coming over from China and so forth just because we want to see it here. And what we're seeing is an opportunity to really regrow that. One of the problems we have is that we're going to create jobs. One of our mantras, right, is not just creating jobs, but creating and filling jobs. So this is where AI, and again, people are familiar. And if you've got a smartphone, you're using AI and so forth. So how do we make it easy for people to use AI? It's not going to replace the people, right? In fact, what happens is the people who will lose their jobs are the people that don't know how to use AI. The other thing we hear about across the board is we don't have enough people to work in manufacturing. And so, okay, how do we make those individuals in whatever plant, whether it's the Lockheed Martin plant right here or that small mom and pop shop supplying them with the nuts and bolts, how do we make those people more effective? Because we just don't have enough people to fill it. So if they can be twice as effective, we can reduce the workforce, but we still have the jobs. And that's coming. And by the way, we're facing that. You should see what the Koreans are facing, the Chinese are facing, and so forth. This is a global issue, and you can bet that it's really going to drive a lot of global competition, whether it's the commercial side or the defense side.
Thank you. Michael?
I totally concur with everything that was just said. And, thinking about Georgia, Atlanta, Georgia Tech, in particular, I think one of the interesting things is, again, the pace at which this technology has been sort of sprung upon us. I've been at software for 25 years. I've never taken a class on agentic software development, right? Those courses really don't exist. And so one of the things that we need from our academic institutions, our research partners is, we need talent. We need talent that's going to, grow up through these sort of programs, learning this stuff from day one. I think, companies have done a really good job making this accessible, but there is a skill level. You just mentioned the people that are going to get left behind eventually are the people that don't know how to use this technology, right? And so, wanting to see curriculums in all sort of applied technology fields, figure out how to train people and how to use these systems to make themselves more productive. I think, thinking about GTRI, who's been a great partner, both to commercial industry and the department, there's a lot of room for, again, I mentioned building trust, policy, cybersecurity around the use of AI systems. There's a lot of research that we need to partner. It's practical, it's applied research that needs to go into answering a lot of these questions on how we make these systems safe. And I think, really just the regions, one of the reasons why Sigma Defense is headquartered in the area, there's a lot of innovation happening in the area around Georgia Tech, probably partly due to Georgia Tech and the talent that you guys are growing. And so I think that there's just an immense opportunity to partner between the department, commercial industry, and academics and research in this area to really push where that innovation is going to go in the next 5 to 10 years. And for the first time in my career, I'm usually pretty good at predicting what was going to happen in 6 to 12 months. This is the first time in my career where I look 6 to 12 months in the future and go, I don't know, we could be looking at something, very different 12 months from now than we've ever seen before. So it's exciting times, and super happy to have a resource like Georgia Tech involved.
Thank you. Now I'd like to open it up to the audience for any questions. I see a hand all the way in the back there.
It's for the audience, yeah. Who's first?
First of all, thanks for the very interesting talk. It was very inspiring. My question is, might go to Didi or General Ray based on not specifically related to AI, but more in terms of the emerging technology in general. My question is I want to hear more about how governments, or especially for the federal side, how governments are actually recognizing or realizing the actual implications of whether this technology first introduced in the civilian side is salient or important in terms of the military or security applications or not. Because as Didi just described, Anthropic have a very use of wide use of the civilian side. Government somehow recognizes those applications for the military and the national security implications. So I just wonder what kind of discussions or indicator that government actually used to recognize those technologies, salience of the technology.
Didi?
Sure. So maybe I'll draw on my experience at the Defense Innovation Unit. In my view, one of the best ways that the government can do this is have very clear requirements and prototyping efforts that allow us to test this technology in different contexts. I think, I hear lots of statements about we want to integrate AI more broadly into our ecosystem. I think that's just very hard for companies to solve for. What is really helpful is when the department comes to us with a specific workflow or a use case. This is what we're trying to do. How do we integrate AI into this process to do it productively and pair that up with the right tools from the acquisition side and the resourcing side to allow us to do that in a way that also bakes in scaled adoption. I mean, that's ultimately how you create a strong demand signal for industry, is you have a path from a requirement to a prototype to a production effort. I think the department has made immense progress in this. I obviously credit a lot of it to DIU. In the past few years, we've gotten very comfortable with using tools like commercial solutions openings that enable this process. Congress has been very supportive of these efforts. They have recently enabled things like flexible funding and budgeting for things in sort of groups of emerging technology applications rather than very narrow and specific programs that don't always allow you to keep pace with the changing nature of the technology. And so I think all those tools have to come to bear in order to, as you said, test and realize the potential of these in national security contexts.
Yeah, I'll take a slightly different take. I'm not disagreeing, but I'll come at this differently. Business executives for national security travels abroad. We look as business leaders at the geopolitics of what's happening. I would tell you dual use technology is one of the biggest drivers for the downfall of globalization. When you look across all the governments in the regions, I had a very serious, accomplished diplomat explain to me, the mistake to make is to say that the world we're in now is a Donald Trump reality. You're in a realist chapter, but across the planet, the optimism of the liberal model is gone because of the economic liability and vulnerability now with the system as it is, supply chains, et cetera. It's gone. And it's not a choice, it's pragmatic. So what you're now seeing is the implications of emerging tech driving lower bars to entry. You're seeing people who are going to play the game differently with different ethics models. So you have a significant bill to pay. Everything new like quantum and AI, you don't just have the luxury of applying it. You now have to apply X amount, but then you have to take Y amount from it to preserve your values and your capability, because those who are less ethical will now commit some of their resources to taking that away from you. So you're in a very different dynamic. That's why I come back to this idea of where we're in big trouble as a nation, because we prototype and we outsource, right? So if you look at and I'll come back to why the states are so important, because you guys are a great example of why that would be. But if you have basic research that comes up with an idea, and I don't think there's a better school out there at doing the applied side than Georgia Tech. I think it's Latin for, go get them problem solvers, and they are just incredible at that. But there's this whole stack where you begin to prototype something and then you scale it. We don't scale. And so we lose all those opportunities of a workforce, of a command of the market across the globe, the resources, the supply chain, all that we now are compromised. And I think that's been laid bare here recently. COVID was a hint, but now we know that we're in deeper trouble with critical minerals. We understand that kind of piece. So the real implication now is you're seeing people come into this defense sector with lower cost things, willing to buy more risk and not go to the DoD as the funder or the scaler. We did a lot of great stuff in DIU, but we don't scale. We could scale networks, we could scale software. The only hardware we scaled as a military is the MRAP, and that's either a movie prop or in the boneyard. So there's a radical change that has to happen in our own economy. We have 7 million young men not working. That's not okay. I mean, there's a lot of talent that needs to be pushed to the next generation of manufacturing and jobs and skills. So there's this, you can see this push now to say we have a different strategic environment and we're behind. I worry a lot more about that piece than I do about whether AI is going to be able by leaps and bounds. States are everything. These are national problems, regional solutions. You have permitting. There's a federal load, but there's a state load. No one's going to choreograph this ecosystem better. Massachusetts has us at Ben's shepherding their national security ecosystem from MIT, Draper, all the way through. It's happening in Texas. It has to happen here in Georgia because your ability to do so much with the resources you have, but only at the local level can you choreograph enough coherence in that ecosystem. It's just not going to happen across the nation.
Other questions?
Yeah, so question for, I suppose, Aditi. So, Claude famously has this constitution, which I think there was a new version of it released just last month. But my question is, what does that constitution look like for, defense and national security applications, right? So I think a big part of it is, you're trying to instill these ethical values in an AI. What does that look like when that AI is tasked with creating, kill lists? And how does that change the nature of that constitution and SOL document?
Yeah, so we have, we call it a constitution, as you said, for Claude. I think all the frontier AI labs have thought about what they want the character of their models to be. So we're no different in that sense. Ultimately, the model is grounded in values to be honest and helpful and harmless. I think in the defense context, what we really grapple with as we think about the dual use nature of our business is how do we enable applications that are legitimate in the context of national security that would be considered harmful otherwise. And so we want to, for example, enable national security professionals to be able to do foreign intelligence analysis. We want them to be able to think through different operational problems. And so we have actually fine-tuned our models for the national security context to allow those sorts of applications, because at the end of the day, what we don't want is the end users to be hampered in situations where they're trying to do something legitimate for the mission that they can't do. And this is where our track record of working closely with the department for the last 1.5, almost 2 years is really important. We don't just release this model into the national security community and walk away. This is a very close partnership where we, as I said, try to understand what it is that users are trying to accomplish and have technical discussions that will enable them to do that. And we've had very positive feedback over the time that we've worked with the department on the model being useful. As I said before, I think it's important for us to think about the implications of how the model is being used. I think we need to be responsible in that. And again, that's where the government is partnering with us, and we hope to continue partnering with them in the future to do that. That is going to be an outcome of the policies that we put in place around our models to make sure that they're being used in responsible ways.
I've tried to pay close attention to what I'm hearing. And as a system engineer, level 3 certified, 50 years, this is a product we're talking about here. We're talking about guardrails, we're talking about security, and a lot of other things. And rather than talk about a constitution or perhaps a performance spec, why doesn't the industry, the big frontier model guys, which includes Elon, I know I've read about the conflict between them, why not spend some time in characterizing what your product doesn't do, because it's not coming across as some kind of deterministic system that can be relied upon by anybody, not just a warfighter, but it's some kind of stochastic process where we're rolling the dice, which I've done before. Again, why doesn't the industry, which is not together at all, unlike the other industries we have, to advise congressional staff members and others and come up with something common? Forget your constitution, which I've read about, and I understand the conflict there, but just better characterize what your model does or doesn't do, as we do all the products that we've got in this world. There is a product specification, and it either does or doesn't do what it's supposed to do, a vehicle, etc. How is this AI product any different?
I think it's different in the way that you're alluding to, and that it is non-deterministic. It is a general purpose model that it's like creating something that has an embedded set of facts and values, and it responds to its environment in different ways. And so the effort is really understanding how does it respond to those different environments, and then putting in the policies and safeguards to affect that behavior. At Anthropic, we invest a lot in red teaming our model. We invest a lot in trying to understand how it responds. So before any model is released, we take that effort across a variety of dimensions. We mentioned some of them today. What can the model do in the cybersecurity domain? What can the model do in the biosecurity domain? How does that compare to what humans can do? And therefore, what does it imply about the policies and safeguards that we need to have in place? And then in terms of just being really prescriptive about how the model can and cannot be used, like, listen, I think that's a conversation that we need to have across the private sector and government, right? I think we need to have that conversation as these capabilities to develop, to say, in what context are we going to allow this model to be used, and what context are we not, and what does that workflow look like? I've spent a significant amount of my time today talking about what that could look like and the different solutions that we could bring to bear, but we are early in that conversation. If you recall, even a year ago, these models were capable of almost nothing. I wouldn't have trusted them to summarize my emails. Today, it is a completely different picture, and as Michael said before, it's very hard to forecast how things are going to look in 6 months and 12 months, and so I do think we need an effort that is holistic across the private and public sectors to think about how we're going to respond to that.
Other thoughts on the question?
Well, before I was rendered intellectually stultified by my current administrative role, I did spend a lot of time looking at the nuclear sector. And in the nuclear sector, there was always a debate between the folks that were looking at the security and the non-proliferation side. And they always had the challenges that were presented by the technology and the single fuel cycle. And you talk to people that were developing new reactors or whatever the technology, and they said sort of, that's not my problem. I'm developing the nuclear energy, you handle the security. And our students today asked the question, which is, you know, in this world that we're talking about here today, on the one hand, as we've heard today, people are talking about the same things. It's not it's not left to the engineers or the policymakers. We've been talking both in the two panels about fusing these things. So my question to you today is that looking back at the nuclear sector, I think where we ended up in this Generation 4 era is talking about safeguards by design and building in these principles, just like we build in cost effectiveness, efficiency, building in national security considerations, resilience, safety. What is it about this world we're in today, from the vantage point of where each of you sits, that makes this either more difficult to think about building things in by design or really where we should be going?
Yeah, so great question. You could go back to the Oppenheimer, Truman, fisticuffs over who invented, who's accountable. I think that was the guy who asked for it, the government got to use it. It wasn't up to the science and tech world to say what it would and wouldn't be done. That's a pretty blunt take, but it falls short, right? But what you got over time was a lot more safety, internal safety measures. We evolved through that, fortunately, command and control, two-person security, et cetera. We're a lot better at that. If it doesn't stay fresh, though, then it loses relevance, right? So I was doing a big project in the Air Force, and some of the things had changed, but nobody had updated the regulatory types of piece. We stack requirements. It's too expensive. You have to kind of get back in to make sure it stays relevant to go back. And sometimes things live long enough that you actually have to go to version 2 because science is different. I think this is no different. You're never going to be done with this. And if you're a society with no values, you could be done. You could be done pretty quick. But I think we owe the world a lot more than that. But the ability to get everybody in the room to have this conversation is a withering chore, the pace of everything. And so there needs to be a way to convene and do those kinds of things and curate. You're probably not going to legislate your way through that. If anybody has any confidence that we're going to legislate quickly, but there's probably policy that creates, and then there's strategies and things that take root. But I think there has to be academia, the business community, and certain, government leaders who encourage this dialogue to evolve through it. This is probably one that's going to move so much faster than we've ever seen before. And I think that's a big piece of the discomfort. But if you don't bake your values into this, and I go back to accountability, authority, and responsibility. As a nuclear guy, there's always a human being who pushes the button. So I will always begin there and devolve away from that. What will I now delegate to make that decision, and what's the right thing to do? And the American people should demand that of us. We should know what our red lines are and then walk back from there, not to say anything's possible, so let's go find the perfect place. It's easier to say, I won't do this. I won't do Skynet or Whopper, right? We'll draw the red lines and then begin to devolve from that. I think it's a smart way.
I wanted to just, sorry, go ahead.
So just a quick follow on, let's say just from the technical package side on that. So, we have been doing things like we've been doing things since sort of the 1991 test ban treaty, because we just don't, we know that worked, and now, we're going to continue on. But our models are much better and so forth. And so this sort of allows us to do things that we couldn't do 20, 30 years ago. I think the real concern I have, and I'll keep this very short, the real concern I have is I think AI is pretty good at interpolating. So we've got data and so forth, we can use AI to interpolate. But what happens is when you say, okay, well, what's next? What's sort of beyond what we know, and we're developing new things, understanding new things, AI struggles there, at least everything, that I've sort of seen, because it just doesn't have data out there. And so I think that there's going to be a balance. I think with things that we know, I think we're going to get stronger, but I think we also need to be able to move our models forward, but from more of a physics-based perspective, as opposed to just, well, let's just throw something at the wall and see what sticks. You definitely don't want to do that on the nuclear side.
Michael, do you have?
Yeah, just a real quick comment, kind of going back to the nuclear systems analogy. I would kind of look at this and think about systems as a whole. So if we think about AI, I might liken that to the fuel in a nuclear reactor or a nuclear bomb, right? The fuel that goes into a nuclear system itself has power. It also has risk on its own. But then when you put it in the system, there's a whole other level of risk and power that comes out of it. And so I think the thing that's interesting when thinking about safety is it's, frontier model developers, but then it's the integrators and the primes that are going to build systems on top of that, plus the policy and security, folks. And that's going to take a real collaboration. And again, the pace at which is evolving, by the time we get the Tiger team set up, we'll be three iterations down the road on this. And so that's kind of, the challenge I see is it's going to take a village to come together with all the perspectives when we look at the systems we're actually going to build with this technology and how to get all those folks on the same page. And to the general's point, it's a bit of a withering task.
We have time for one more question.
I guess I was going to ask General Ray. You talked about accountability and delegation, and whether it's on this or some strategic system. If I think about 521056, right?
Get a little closer.
If you think about 521056 and how the obligations for use of force decisions, we ask folks to have objectively demonstrable evidence associated with those accountability decisions. And we've heard about these systems being probabilistic. We're deploying capabilities we didn't even know about a year ago. For physical systems, we have tests and training. We exercise them regularly. Even for strategic systems, we're launching regularly to demonstrate performance and ensure reliability. For these systems for which we've not had the experience, for which we're fielding very quickly, for which we're rapidly integrating these technologies into critical decision loops, how should a commander have confidence that these systems should and will perform as expected when called upon in these kind of roles? How can you have confidence that you can be accountable for systems that are evolving this rapidly?
It's an incredibly difficult chore. So, I mean, I grew up flying B-52s, and I was told what I would do, and then I was told I would never do. And on the first night of Iraqi freedom, I'm just checking off the things I was told I would never do, as I was doing them. So the uncertainty in the environment that you're going to be in is absolute. It's always going to be there. There has to be a sense that you can wed it to the risk that's related. So my colleague talked about the war on terror and prosecuting those things and the constraints. Somebody said, look, we have a greater strategic liability for doing something wrong than we do aggressively prosecuting this campaign. Will there be other campaigns where that calculus is gone? Absolutely. When the Cold War ended, we got kind of lazy as a country. We never really tested our systems beyond what was required to do the war on terror, right? So we didn't economically compete because we ran the system. We didn't change the foundations of our military. We got better at data because we had to find the next 9/11, et cetera, et cetera. But you now have to come into this with this acknowledgement that the next one could be for an existential set of outcomes. And you can choose the existential. You could say England in the 18th century versus England now. They're still England, but they're not the same England. Or you could say you're gone. But if you don't come into that knowing that that's on the table from the very beginning, you can't draw your red lines and then devolve back from it, right? Because if you take I have got sanctuary and I could do whatever I want, I'm not going to have any concerns, then you'll draw your red line differently. But you need to know when you would do something, right? So when would you begin to break rules? When would you say values are nice, but survival is more important? And I think it's embracing that reality that 2026 is you're in that environment now. And that's different. So if you take that kind of consciousness into it, then you can create that right kind of set of devolving things. I had guys working for me that were afraid to break rules. I would teach my 1 stars and 2 stars, you got to know when to break the rules. You just can't break them all the time. There's certain times where you have to break them or you're just not going to be successful. COVID was a great example where you had to play a fundamentally different game. So I think there's this embracing of the strategic environment that you're in, drawing your red lines and evolving back from that. But then there's a training of those leaders, those echelons below you, that you're playing for different stakes. One of the DepSecDefs was talking to me when I was in Europe. I was the deputy over there, and he said, "What can we do for you?" over here to prepare for Russia. And I said, first thing you have to do is walk away from the targeting collateral damage mindset that animates the war on terror. Because there's no way I could keep that particular set of criteria in place and fight the Russians. It's not going to work. I'm not saying, hey, let's just throw all the rules out. But you have the luxury of being conservative and less conservative. And you've never really had to test that in our generation once the Cold War ended. So it's embracing that reality is a beginning point, I think is the key. Does that get anywhere close to? Well, obviously AI is an application, right? So where will you use it, under what conditions, and what will you delegate to it? What would I delegate to another commander? How wide would I give his authorities? How wide would I let that officer go? But it was incumbent upon me to set those foundations and those boundaries. They needed to know when they were going to bump up against one and then elevate the issue to me. But the faster you could choreograph those authorities and make sure people knew when to call, the better you're going to be. And that's what you're going to have to do, is bake in that reality. When do you change the setting on the AI? You know, you're under these conditions, go to 11, so to speak, on the dial, and you have to play the game differently. But you're going to have to think of that as an input.
Well, unfortunately, that's all we have time for. Something as I reflect on this, the importance of partnerships has come up in both the last two conversations, from the defense perspective, from the private sector perspective, and how important it is to, as much as possible, be in conversation with each other across these sectors if we're going to do this right. I want to thank, first of all, our panel for joining us today and sharing their insights. If you join me in giving them a round of applause. And to close it out, I'll turn it over to Adam. Thank you.
Please, I want to reiterate my thanks to the panelists as well. And I want to thank all of the panelists and all of you for spending the day with us. As I mentioned at the very beginning, this is really just an effort to set the edge on this topic. We've just really scratched the surface and at a pretty high level. But stay tuned and please join us as we navigate this path, both here in Atlanta and with our partners in Middle Georgia, as we begin to bring the community hopefully together. Because as was mentioned, especially in this last panel, there are a lot of equities in this state on these issues. It really involves the folks working on basic science all the way to those that are working on strategic issues and mom and pop shops across the state. So I think we're all in this, whether or not we like it. And I'm hoping that the Nunn School can work together with our colleagues across Georgia Tech and GTRI to really be a fulcrum for this discussion moving forward. So thanks again for spending your day with us, and we look forward to seeing you in the future. Take care.